So see how we are using this algebra in the mathematical modeling, because these two are very entirely different fields. So where we in modeling we simulate the result, and that simulation we have to validate our result by some different means. Machine learnings are very important, means naive Bayes method, CNN, and so many computer engineers are using this type of methods. But rough set method is very new for our even in India, and it's not a subject, because in our NIT Raipur, I have introduced as a subject or even open electives, and the students are taking these subjects with last 2 years, and they are benefiting by this, and they are preparing much paper, and they are using in their research, because this is very important for validation of results. Because if we want to validate our results, we have data. So which on the background of data, the these rough set topology, means interior and exterior closure, we can approximate the result, and we can find our data, or find our simulations in very good manner, and we can show that our result is up to 90% accuracy or 95% accuracy. So these methodology is very helpful in our research. So please, just I am showing some fields where we have used this algebra in this rough set theory. Please, next slide, please. Yeah. So ultimately, in disability relations, back some, please back one slide. Yeah, yeah. Please back. Yeah. Next. So next, please. Here, equivalence relations. We know that the equivalence relation means all know what is equivalence relation. So that relations x theta y theta. So it is equivalence relations means satisfy all the three conditions. Please next. So indisability relations is very important. Indisability relations means where we can find the similarity in disability. So similarity we can find, and we can approximate that the equivalence class can be x ind b, y belongs to u, and x ind b belongs to y. Please next. So if we can see that we can a non-empty sets age, lame, or so one attributes is age, another attributes is lame, and age and lame is the two attributes. On these two backgrounds, we can find some decision who can walk and who cannot walk. So if we find IND age, IND lame, and IND age lame, so we can find this type of mathematics. Means what are the similar? Just I am explaining for age, x1, x2, x6, 1630, 1630, and 1630. So this is one in one set. Another one x3, x4, the same set, x5, x7, like that, age lame and age lames. So we can find this type of indisability. And this is very backbone for indisability in the data. Means date, if we have data here, capital S and small s, they are having the different meanings, because it is a case sensitive. So we can, when we make a password for in our Gmail, Google Mail, so if we caps lock, if we do caps lock, that this is the meaning of that, this is different. So this is also a type of even indisability relations, because they do not know that a small s and capital S are both are the different characters. That's not same characters. So in that way, in disability, we can define. Please next. Next. So yes, please. Just this is the definition of set approximations. When T means even decision system, U, A, T, D be the decisional system, B is a subset of AT, and X is subset of universal set. So we can approximate lower approximation and upper approximations. Already that B lower approximation, that type of element in U which are exactly contained in X, and that type of element of U which are XB and U is not FT, means they are closer. So this is upper approximation, this is the lower approximations. So these two approximations make a rough set. So please next. So ultimately, now boundary regions means if we subtract from upper approximations minus lower approximations, what are the elements we can find? That is called in the elements are in boundary regions. So in rough set theory, boundary region is very important. When the boundary region is empty, there is no rough set. So for rough set, some elements in boundary must be there. If it is there, then it is rough set. If it is not there, then it is not a, it is a script set, means only set, classical set. So that is the difference between set theory and rough set theory. So this is the outside boundary, and so the pair lower approximation, or we can, so in the change we can change also lower approximation upper approximation, or upper approximation lower approximation, both type of even notations we use, that type of set, the pair is known as rough set for any type of data. Please next. So here example of approximations, just next example. So this is the similar, we can explain how we can find rough set in the data set. Yes, next. Here examples of set approximation, another lower set and upper set, and this is a different example. Please next. So this is the pictorial presentations. The decision x1, x6 is yes, that x2, x5, x7 are no, and in boundary x3, x4 are in the boundary regions. Please next. Here also we can measure accuracy of approximations. So we can also approximate, means the cardinality of lower approximation upon cardinality of the upper approximations. Please next. So rough set in the term, rough set also can be expressed in the membership functions. So please, here we also that we define, not we define, that Pavlak has defined XB is target set, and that indivisibility relations, upon this we can find the membership functions. Please, this is the next. So here the pictorial presentations, that when the this is zero, there are two different sets. When this is embedded in this, the approximation is, membership function is 1. But when it is the membership function from open interval 0 to 1, then it is a rough set. So for rough set, the membership means boundary region is very important. Next, please next. So in the difference between set theory, the thickness of concept is represented by boundary region, where the fuzzy set theory thickness of concept is presented by degree of membership functions. So thickness of concept is represented by boundary region. So the in rough set theory, boundary region is very important, whereas in fuzzy set theory we know the membership function is very important. So next, please next. Some applications only I have skipped the slides. Please next. Yeah, next. Application of rough set in noise reductions. When we have data in some data, always we some when we find the data with noise. When we talk about some in phone, we just interrupted between the even some disturbance. How we can reduce the noise, or in we reduce the noise, or we reduce the imperfectness or in vagueness. So we can apply this. Yes, please next. Next. Like these are the methodology we have used. Whom to, if you want to understand, you can contact to me, because this is not a time to explain everything. This is the mathematical background. I am only showing what is the importance and what is the backgrounds of that, where we can use these things. Please next. So these are the goals of reductions. Please, yeah, we can find reducts, means we have very big data, we can find some very much most important characteristic between these by this using. And please next. And in this next, next, please next. Using this means we can find redux means the possible, yeah. And ultimately after that, what are the most important features that is known as core. So redux and core are very important, means every data we want to reduce the, means if we have very big data, so by this big data we don't know what is the importance of this, because even something even today we know that the even NEET case, so much big data, 23 lakhs students are appearing in this, and the data has been put in IIT Madras, please. And even see Chandrachud means the Chief Justice has told that please find by this data whether the cheating has been done or not. Now it is very big crucial by these data how we can say that the cheating has been done or some corruptions has been done. But they have used this rough set theory, and by this data they found that there is no cheating, and whatever the different things are, that is the different, it is a political matter. So please, because we are mathematicians, so now the we can find this that redux and core. Please next. These are the methodology, only methodology. These are, please next, 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 please. These are the methodologies because yes, please next, 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 please next. These are totally methodology to find the redux and core from the data. Please next, next, next. We can find some pattern also. By this pattern, we can find some, means we follow this pattern by data. We can say that the situation are handling like that. So we can also find by this. Okay, next, please. Uncertainty optimization based noise reductions. Please next. So we have published one paper, uncertainty optimizations. So this is a work. Please next. Next. These are the even methodology we have used. Please next. Next, next. These are the methodology. Now also one paper we have published in computational economics. Please next. Computational economics, it is a SCI generals, means uncertainty optimization based feature selection model for stock marketing. So we can say we can say that the even Rupset theory also used in stock marketing, and in which situation we can find more gain, and in which situation we have to not sell the our shares, we can find. So this paper we have published. Next. So these are the methodology we have used. Next, please next, next. These are the patterns. Next, rough set theory also we have used in algebra. Means we can say that we have used rough set theory in different fields of mathematics and science and technology. Please next. Even rough set theory, rough group, that is defined by one even mathematician by Poland. And these are the next. Next, please, next, please. These are the examples of NUF group. Please, next, next. So this is the published paper. Next, rough subgroup. Next, rough subgroup examples. Next, we have published one paper, injective module based on rough set theory. Because actually I am a student of algebra, and my even some on some dual concepts in modules in algebra. That was my topic in PhD thesis, which was I have done under Dr. S. and Dive sir. So that even I have just, so a projective module, injective module we did in our MPhil course. So we have just even formulated in rough set theory, and that public is published in Cogent Mathematics. Please next. Ideals offering in a rough set. Next. Rough projective module. Next. Roughness in free module. Next. So these are the publications which we have published in even SCI Scopus Journals. Please next. Now, after that, I think that can be done in also real world problem. So we have applied that rough set theory in bioscience and bioinformatics. Please next. Application of rough set methodology accurately predict the unknown protein class Leishmania donwani membrane protein. It is it's a disease Leishmania donwani, and ये अपंग कर देता है बच्चों को, पैरालिटिक अटैक करता है. So how we can find that, where we reduce that type of data, means that type of cases we can, that we have applied. And so please next, that that is mathematical bioscience. We have published rough set methodology accurately predict unknown protein class family Leishmania donwani membrane protein, means it's a perfect method for prediction where we don't know the decision in the experimental lab. When experimental lab fails, we use our mathematics, whatever mathematics. And also we have shown that our mathematics is up to 95% accurate. So also we have checked by different computational machine learning language, and we have confirmed that our result is more than 95% accurate. So please next. These are the even literature. Please next, next, please next. These are the feature selections, and these are the methodology we have applied. Next, please next, 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 please next. Testing and training. Yes, please next. You see, please. Here you see, rough set method has the accurately 89.2%, naive base 76%, RF 73%, SVM it is 63%, and C 4.5. So like that. So in that way, we can say that our method is a very popular and very important method. Please next. So, mathematical model of adiponectin resistance. Adiponectin resistance, we know that means it is inversely proportionate with our leptin. Means where with the sugar patients, how we can reduce our level adiponectin, how we can increase our adiponectin. So these are the things we have applied in mathematical modeling. Means we have applied in rough set theory in mathematical modeling also, and we have published one paper, please, in the Journal of Theoretical Biology, a mathematical model of adiponectin reptin. So this is also SCI Journal in the elsewhere, and we have published. So we are using rough set theory in different branch of engineering and science. Please next. These are the literature reviews and in that paper. Please next, please next, because we have less time. Next. These are the graphical representations. Next, please. Now, next one is the another work is feature selection and pattern recognition of different type of skin diseases in human body using rough set methodology. So we are here also we have used rough set theory for finding the skin diseases, types of skin diseases. So we are using this in the mathematical bioinformatics. Please next. And these are the some cases. Please next, please next. Another one is mathematical analysis and computational approach for tumor growth in human body with a significant technique and rough set theory. Yeah, only 1 minute. So please, these type of even methodology we have used. Please do the fast. Yes, these are all. So just I am complete concluding my, because the main program just we have to start. Oh, thank you very much. And if any questions will be there, you can contact with me. Thank you.
Okay, thank you, Professor Sinha, for this nice talk. Because of the shortage of time, we will not be able to give you chance asking any questions. But I think during the conference, we will be having a chance to ask to engage you. Thank you very much.
Sorry, we are just waiting. Our chief guest, Professor Nilamri Dave Madam, has already arrived. We are waiting for a few minutes. Our Honorable Vice Chancellor is coming.
はい。जिसका वो खराब है, सर को बोलना। सर ऑन करो। बॉस हेलो बोलो हेलो। उधर है। हाँ तो यही चलेगा सर, ये हटा दो।
हेलो।
सही कर दीजिए।
माइक से। हेलो। आवाज नहीं आ रहा।
Hello, hello. Hello, 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 hello. 1 2 3 4 1 2 3 4. Hello, hello.
Hello. Hello.
एक सेकंड ना. हाँ.
Hello. Hello.
1 2 3 4 1 2 3.
As our guests have arrived, we would like to request our guests to please have a seat, sir. Rehearsal. Our guests have arrived. We would like to request our guests to please have a seat, sir. A very jestful good afternoon, everyone. My name is Pushprata Sharma and I am the Vice Chancellor of Dignitary
It is an honor to welcome you all to this exciting and intellectually stimulating celebration of Mathematics Day. Today, we come together to honor the profound impact that mathematics has on our world and to explore its beauty, power, relevance in shaping our lives and future.
यथा प्रीणति भूतानि सगच्छन्ति यथा सदा गणितं तं हिं त्वं पश्यन्ति सुखदा गतिम्. It means mathematics governs the movement of all things and it is the guide to harmony. You do not see it, yet it moves in perfect order, leading to happiness and unity in the world. This day marks the birth anniversary of legendary Indian mathematician Sir Srinivas Ramanujan. It's tribute to the legacy of his extraordinary contributions to the world of mathematics. And it continues to inspire generations of mathematicians, scientists, and thinkers. His work reminds that mathematics is not only about numbers and formulas, but about curiosity, perseverance, and discovering patterns in the chaos of the world.
In this occasion of Mathematics Day, our mathematics department has organized an international seminar on application of mathematics in science and technology. Now, proceeding forward, on behalf of Mathematics Department, like to invite Honorable Vice Chancellor Professor Alok Kumar Chakrawal sir, Honorable Madam Professor Nilambari Dave, Registrar Professor A.S. Randive sir, Dean of Mathematical and Computational Sciences Professor P.P. Murthy sir, Head of Mathematics Department Professor A.K. Thakur sir, and Organizing Secretary Dr. Kankan Sarkar sir to lighting the lamp to worship Goddess Saraswati and pay tribute to legendary Indian mathematician Sir Srinivas Ramanujan.
Following this of Atithi Devo Bhava, that is guest is our God, we would like to invite Professor A.K. Thakur sir to honor our Honorable Vice Chancellor, Professor Alok Kumar Chakrawal sir with bouquet.
Next, we would request Dr. Uma Devi Patel ma'am to honor our Honorable Professor Nilambari Dave ma'am.
Following this, we would request Dr. Dhananjay Gopal sir to honor Registrar of our university, respected Professor A.S. Randive sir.
After this, we kindly request Dr. Manish Kumar Gupta sir to honor Dean of Mathematical and Computational Sciences, Professor P.P. Murthy sir.
In this series, we would like to invite Dr. Koti and V.V. Vara Prasad sir to honor Head of Mathematics Department, Professor A.K. Thakur sir.
After this, I would request Dr. B.B. Chaturvedi sir to honor Organizing Secretary of this international seminar, Dr. Kankan Sarkar sir. Following this, we would Dr. Hapka University of Johannesburg, Auckland Park 2006, South Africa.
After this, I would like to invite Dr. Manish Kumar Gupta sir to present bouquet to Professor Arvind Kumar Sinha.
Next, I would like to request Dr. Amar Pandey sir to honor Professor Dilip Kumar Jaiswal sir, SRM University, Lucknow.
Next, I would like to invite Dr. J.P. Jaswal sir to present bouquet to Dr. Anand Kumar Tiwari from Triple IT, Allahabad.
Next, I would like to request Dr. Santosh Verma sir to present bouquet to Dr. Ambrish Kumar Tiwari sir, Department of Applied Sciences and Humanities, Rajkiya Engineering College, Mainpuri, UP.
Next, I would like to invite Dr. Dhananjay Gopal sir to honor Professor S.P. Singh sir.
Next, we would like to request Dr. B.B. Chaturvedi sir to honor Professor M.M. Singh sir with bouquet.
Next, I would like to invite Dr. Koti and V.V. Vara Prasad sir to honor Dinesh Maji sir.
Now, we would like to invite Head of Mathematics Department and convener of this international seminar, Professor A.K. Thakur sir, for welcome address.
Good afternoon to all of you. I feel honored and privileged. Esteemed delegates, distinguished speakers, and respected guests. On behalf of convener of the seminar, it is my great honor and privilege to welcome all of you to this international seminar. We are truly excited to have many brilliant brains gathered here from different corner of the world. This seminar has served the unique platform to across the cultivate, exchange, and collaborative research and advancement knowledge in our interest. First, I would like to welcome respected Professor Niravali Dabe Madam for his presence and blessing and motivations. I would like to welcome our Honorable Vice Chancellor Sir for his constant help, blessing, motivation, and guidance that are radiated the source of energy for all of us to formalize the conduction of this international seminar. I welcome you, sir. I welcome our respected Registrar Sir, yes, Randive Sir, respected DSW Sir, respected Finance Officer, respected COE, respected all deans, head of department, and faculty members and non-teaching staffs for this international seminar. Thank you all.
Thank you very much, sir. Now, we would like to request our guests to release the abstract booklet of International Seminar on Applications of Mathematics in Science and Technology. As mathematician Shakuntali Devi said, without mathematics, there is nothing you can do. Everything around you is mathematics and everything around you is numbers. Next, we would request Dean of Mathematical and Computational Sciences, Professor P.P. Murthy sir, to share few words.
Good afternoon, one and all. I am very thankful to our Honorable Vice Chancellor, who is very, very busy, even today also, but giving some time to us. Respected Chief Guest, distinguished guest, esteemed speakers, faculty members, research scholars, students, and friends. What can I say about our beloved Vice Chancellor, Professor Alok Kumar Chakrawal? Since joining this university on June 24, 2022, he has made an extraordinary difference. A visionary and a dynamic leader, our young Vice Chancellor exemplifies tireless dedication to transforming the university. Under his inspiring leadership, the institution has achieved an A++ NAC accreditation. Please applause for this. Accreditation and witnessed significant infrastructure advancement, setting new benchmarks in excellence and innovation in education. And yesterday, our Honorable Registrar himself said our professor is going to get an Excellence Academic Award in Raipur. So for this also. Sir, we are almost, you can say that around 10,500 total members of this university, and if Vice Chancellor is getting this award, means each one of us getting one by something. So we are also honored for your Excellence Award. Behind every great leader is an unwavering support, and Professor Nilambari Dave, former Vice Chancellor of Saurashtra University, Gujarat, is truly treatment for this. Her consistent encouragement and wisdom have been a cornerstone of this university's rapid growth and success. Her presence adds immense strength to the vision of our Vice Chancellor, making their combined efforts a remarkable force for progress. My senior colleague of the department and my dear friend, Professor Abhay Randive, who has been on many positions of this university, and right now he is the registrar of this university. One thing I can say in one word, I can explain, his table is always, you can find clean. There is no file. And he's sending to our Vice Chancellor, and Vice Chancellor table is immediately cleaned. So that is what these two offices are working. It is my great pleasure, privilege, and honor to welcome you all to this international seminar on the occasion of Srinivas Ramanujan National Mathematics Day celebration organized by the Department of Mathematics, Guru Ghasidas Vishwavidyalaya, Bilaspur. Today we gather here to celebrate the birth anniversary of one of our greatest mathematical geniuses the world has ever seen, Srinivas Ramanujan. This occasion is not just a tribute to his extraordinary contribution, but also a celebration of passion, perseverance, and brilliance that he brought to the field of mathematics. Born on December 22nd, 1887, in a small village in Tamil Nadu, Srinivas Ramanujan overcome immense hardships and challenges to become a beacon of mathematical brilliance. Despite having no formal training in mathematics, his profound insights into number theory in finite series and continued functions changed the landscape of mathematics. His collaboration with G.H. Hardy at Cambridge University highlighted his unparalleled genius, and his legacy continues to inspire researchers, students, and educators worldwide. This seminar is a platform to bring together renowned academicians, mathematicians, researchers, and young minds to share their ideas, explore developments, and inspire innovations. Mathematics as a discipline is a backbone of science, technology, and numerous applications in modern society. By honoring Ramanujan's contributions, we aim to motivate a new generation of mathematics and research to push the boundaries of knowledge. On the behalf of the School of Mathematical and Computational Sciences, Mathematics, and my own behalf, I extend my warmest welcome to all our honorable chief guests, our keynote speakers, and participants. Your presence today add immense value to this occasion, and we are truly honored to have you with us. I would like to welcome the faculty members, research scholars, and students whose dedication and participation make this event possible. Your enthusiasm mirrors the spirit of Ramanujan, curiosity. Thank you for inviting me for address. Thank you a lot. Once again, Professor Kumar Chakral, our Honorable Vice Chancellor, to be here. Thank you, sir.
Thank you so much, sir. Mathematics is a tool for reasoning and understanding the world, not just a collection of rules and techniques. Now, to share his insights, we would request the senior most faculty member of Mathematics Department and presently Registrar of our university, respected Professor A.S. Randive, sir.
Honorable Vice Chancellor, sir, Professor Nilambari Devi Dave, the First Lady of this university and ex-Vice Chancellor of Saurashtra University, Dean School of Mathematical and Computational Sciences, Head Department of Mathematics, and the convener of this program, Professor Sarkar. Sitting in front of me, my PhD supervisor, Professor S.P. Singh, some of my students, my colleagues, and various experts coming from almost every part of India as well as from certain foreign countries. The students sitting in front of me and those who are going to present their papers. I was just going through the abstract, more than 11 invited talks and around 122 papers to be presented over here. And I'm not able to avoid myself calling my earlier days in this university when I joined for the first time on 17th of July 1989, and I was the only person in Department of Mathematics. I joined, and for almost uh, 3 months or something like that, uh, we had to do everything. You are all in one. You are teacher, you are babu, you are peon, everything. I was sharing my room with one of my then colleagues from Department of Commerce, और जहाँ छत पर से बंदर दौड़ते थे तो एस्बेस्टस शीट सर पे न गिरे इसलिए टाट लगाई गई थी, टाट पट्टी, कि ताकि आप सुरक्षित रहें। मैं अकेला ही चला था जाने पे मंजिल तरफ, लेकिन लोग आते गए, कारवां बनता गया। आज जब इस विश्वविद्यालय के इस डिपार्टमेंट ऑफ मैथमेटिक्स में 122 पेपर प्रेजेंट हो रहे हैं, 11 इनवाइटेड टॉक्स हैं, कहीं एक संतुष्टि का भाव है। लेकिन अगर मैं स्पेन ऑफ टाइम देखूं तो ये स्पेन ऑफ टाइम बहुत लंबा है, और जो 3.5 years का अभी का स्पेन ऑफ टाइम है वो बहुत शॉर्ट है। And those who are closely associated with this university only can understand what dramatical and drastical change we are observing for these last 3.5 years only. And all the credit goes to our dynamic, beloved Vice Chancellor, Professor Alok Chakrawal. I'm also happy to note that Department of Mathematics has submitted data in various platforms, but as far as I understand, Department of Mathematics will be having highest number of publication in IRF list if we count. Let's hope for the good. Although this has yet to be declared, it will be a premature statement, but I hope we will be among top 1, 2 or 3, and I hope for top first position. Let us see what is going on. एक लंबी दूरी है और मंजिलें अभी और भी है। लोग आएंगे, लोग जाएंगे, डिपार्टमेंट की प्रगति बनी रहे। डिपार्टमेंट में इतने अध्यापक हैं, इतने रिसर्च स्कॉलर्स हैं, और ग्रेजुएशन और में पिक एंड चूज करने की स्थिति है। सेमिनार हो रहे हैं, लेकिन हॉल छोटा ही लिया जाए। कुछ बच्चों की परीक्षाएं चल रही हैं, कुछ बच्चे कुछ ही और कार्य में व्यस्त हैं, और फिर भी यह हॉल फुल है। यह देखकर मुझे बहुत प्रसन्नता होती है। मुझे याद आ रहा है कि हमारा मैथमेटिक्स डिपार्टमेंट का पहला कॉन्फ्रेंस जब हुई थी, तब इसके तिहाई हॉल में कॉन्फ्रेंस हो गई थी, बिकॉज द यूनिवर्सिटी वाज हैविंग ओनली अ फ्यू टीचर्स. We were only 17 teachers and few invited speakers, and so from that step up to this step, it is a change which I could see, I could understand, and I could be happy to note. I wish this conference a great success, and not only in terms of papers. I've just listed. This conference should give you a chance to interact with all other disciplines, and especially to the youngsters who are students who are presenting their papers and who are aspiring for their PhD degrees. They should take this as an opportunity to interact with the experts on various subjects. And I'm more than sure that this will give them a chance to understand their own topic, their own subject from a new idea, new concept, and another angle of studies. Thank you for inviting me over here. Thank you.
Thank you so much, sir, for inspiring words. Now, I would like to invite Dr. Bijendra Paswan, sir, to present bouquet to Professor S.D. Diwan, sir.
Nextly, we would invite our chief guest, Professor Nilambari Dave ma'am, the former Vice Chancellor of Saurashtra University, Rajkot, Gujarat, to express few words.
हम सब में विराजमान परम तत्व को मैं प्रणाम करती हूँ. Good morning, all of you. Honorable dignitaries on dais, off the dais, and dear students. के जमाने में मैथमेटिक्स I just learned the implications of mathematics in जो प्रैक्टिकल इम्प्लीकेशंस है मैथमेटिक्स के वो आप लोग एक्सप्लोर करेंगे. वैसे मेरा फाइन as well as pi. तो आज मीन्स मैथमेटिक्स जो है कंप्यूटर एप्लीकेशंस में तो ही है, बायोलॉजी में भी है, और ट्रेन की पूरी सिस्टम जो है इंडिया में उसमें, और ऐसी काफी सारी प्रैक्टिकल implications है. Where mathematics, she said, every now and then हम लोग ये भी में कितना टाइम लगेगा, कितने स्टेप्स लगेंगे. सुबह से शाम तक हम लोग मैथमेटिक्स को जीते हैं. तो I congratulate the organizer and totally इसका 2 दिन का जो सेमिनार है उसको इफेक्टिव शेप देंगे और नॉलेज एक्सप्लोरेशन में काफी हेल्प होगी. थैंक यू ऑल. आई विश ऑल द सक्सेस. सबका शुभ हो, सबका मंगल हो. जय भारत, जय हिंद.
Thank you very much, ma'am, for your gracious presence. Now, we would like to invite the Dynamic sir, whose visionary left our Central University in one of the top 10 universities in the country, have inspired. Sir.
दीपशिका, गुस्से में क्यों बोल रही हो? आज इस इंटरनेशनल सेमिनार ऑप्शन बहुत स्वागत है. प्रोफेसर अरविंद कुमार सिन्हा जी, आपकी हमारी श्रीमती बड़ी प्रभावित थी, बता रहे, बड़ा बढ़िया बोल रहे थे आप. चलो मिल गया. प्रोफेसर सैयद मुदस्सिर हुसैन साहब आए हैं कि नहीं आए? आज नहीं, ऑनलाइन है. अच्छा, ये राजा भाट तो यहाँ मैं जाके आया हूँ, शायद आपके धनंजय ने भेजा था, किसने भेजा था? प्रोफेसर दिलीप कुमार थे या नहीं? वाह भाई, बहुत अच्छी बात है। प्रोफेसर एएस रणदीवे सर आप नहीं है। प्रोफेसर राजेंद्र जी नमस्कार सर, आप जोहान्सबर्ग से बहुत अच्छी बात है। सुभाष खजांची जी, अच्छा, इज नॉट प्रेजेंट हियर। डॉक्टर आनंद कुमार तिवारी जी नमस्कार। अमरीश कुमार तिवारी जी नमस्कार। तो गणित के लिए अब मैं क्या हूँ, दुनिया गणित में लगी हुई है, और जिसका गणित ठीक हो समझ लीजिए जीवन में कोई समस्या नहीं है। हम कहे न 3 में है न 13 में, हमने कहा ये 3 चक्कर क्या समझ गणित का उन दोनों से बात करिएगा, उसकी उससे मत करिएगा। तो जैसे ही आप वहां जाओगे सब 9 2 11 हो जाएंगे। फिर गणित आ गया, समीकरण। प्रोफेसर जी और मैं और एक प्रोफेसर राजेश रावल जी, हम लोग जो है एक कहीं उड़ाका दल समझते हैं कि नहीं समझते, फ्लाइंग स्क्वाड। तो जूनागढ़ में एक कॉलेज, राजेश रावल बीच में निकल गए, तो हम दोनों ही गए। तो प्रिंसिपल हम लोगों को दोपहर में खाना खाने के लिए लेके गया। इनका निलंबित है, मेरा नाम प्रोफेसर आलोक चक्रवाल, वो सामने बैठा हुआ है, हम लोग इधर बैठे। सहज रूप से या तो मैंने इनकी थाली से कुछ उठाया या इन्होंने मेरी थाली से कुछ, और वो बड़े गंभीर निगाहों से हमको देख रहा है। अच्छा, करीब 23 साल पुरानी घटना मैं बता रहा हूं। तब इनको लाइट हुआ, गुजरात में उसको बोलते घोंका मारना, ठोहा मारना, पर घोंका मारा। तो हमने कहा શું છે ઈ છે કે શું જોયે છે, પછી જાણું મને એટલે ગુજરાતી में हमने कहा भाई साहब आप कुछ और मत समझे, हम लोग का कुछ ऐसा वैसा संबंध नहीं है, हम लोग पति पत्नी है। क्या अच्छा एम हम जाणू। तो अगर माँ का समीकरण ठीक ठाक नहीं है तब भी समस्या हो गई। एक छोटे बच्चों की कहानी सुना रहा हूं, है ना। तो बच्चों में आपस में बहुत तरह की स्टोरी चलती है। तो आलू है ना, आलू आलू भिंडी के प्रति आकर्षित था, तो था, और भिंडी ने उससे दोस्ती ठुकरा दी। आलू बड़ा उदास हो गया। तो भंटे यानी बैंगन ने कहा तुम क्यों उदास होते, मैं तुम्हारा दोस्त हूं ना। तो आलू और बैंगन की दोस्ती हो गई। उस दिन से आलू ने कभी टमाटर के साथ दोस्ती की, कभी गोभी के साथ की, कभी पालक के साथ की। आलू हर सब्जी के साथ चलने लगा। अब भिंडी देख भी दोस्ती कर लो, गणित का वही मसला। ये सब विषय के साथ इनकी दोस्ती है। ऐसा ऐसा जहां गणित नहीं है, ठीक है ना। मैं एक जाकर के मतलब बड़ा कई बार क्या होते हैं कि सी होते हैं ना, एक ट्यूशन वाले के यहाँ जाके चिल्ला रहा था कि तुम्हारे पैसे आप वापस, क्या आपने साइन थीटा कॉस पता नहीं क्या क्या सिखाया, कहीं उपयोग में ही नहीं आता है, ऐसी चीज सिखाइए। तो उसने उसको बेसिक गणित नहीं सिखाई थी। बेसिक गणित जो है अगर किसी ने सीख लिया तो जीवन में कभी निष्फल नहीं होगा। हमारा सब कुछ, हमारे एक घोष साहब थे डीके घोष। तो घोष साहब जैसे ही कंप्यूटर शुरू शुरू में आया और तुरंत वो कहने लगे मैं गणित का आदमी हूं, मैं ही कंप्यूटर पढ़ाऊंगा, ठीक है। फिर फिजिक्स वाले कहे हम भी जानते हैं कंप्यूटर, हम भी पढ़ाएंगे। फिर इलेक्ट्रॉनिक्स वाले कहे हम भी कंप्यूटर जानते हैं, हम भी पढ़ाएंगे। तो कुल मिला जुला करके बात यह है कि मसला केवल गणित का है। वो जगदीश चंद्र बोस का एक, वो ढाका में पढ़ते थे, और उनको फेल करने के लिए पहला वाला सबसे कठिन प्रश्न पत्र दे दिया गया, प्रश्न दे दिया गया। वो सॉल्व करते गए करते गए करते गए और अंत में पता चला कि उन्होंने एक स्टेप आगे जा करके, जहां तक मैथमेटिशियन अभी उसको सॉल्व नहीं किया था, उसके आगे भी रामानुज का भी वही किस्सा था ऐसा कुछ। और ब्रिटेन में इनके ऊपर काफी शोध किया गया। जोक्स अपार्ट, लाइटर टोन की बात अलग है, मगर गढ़ विषय अगर जिसके ऊपर सही तरीके से काम किया जाए, मुझे लगता है कोई भी विद्यार्थी, कोई भी अध्यापक, कोई भी शोधकर्ता कभी खाली नहीं रहेगा। और मैं अभी जब स्पेन में था, कुछ लोग आए थे मिलने के लिए, और स्पेशली उनका अट्रैक्शन मैथमेटिक्स की तरफ था। धनंजय शायद कई बार जाते रहते वहां पर, तो कौन से आए थे मुझे नहीं पता, पर कुछ लोग मिलने के लिए आए थे। दुनिया के किसी भी देश में जाता हूं तो मैथमेटिशियन और आपके विषय की डिमांड अनंत काल। मेरा एक केवल आपसे निवेदन यह है कि आप काम छोड़ने दीजिए, एवरेज काम करना छोड़ दें। ऐसे क्वेश्चंस पर ध्यान दें जिन पर अभी ढंग से काम नहीं, ऐसे प्रॉब्लम्स पर ध्यान दें जिन पर अभी काम करना बाकी है, जिस पर अभी भी वेस्ट ये सोच पड़े हुए मैथमेटिक्स में कि कोई और आपको अवार्ड मिलेगा। मगर श्रेष्ठता और उत्कृष्टता तभी आती है जीवन न्यौछावर कर देते हैं। रामानुज ने कभी ये नहीं सोचा था कि हमें जीवन में अवार्ड चाहिए। उन्होंने पूरा जीवन अपना समर्पित किया, तब जाकर के आज पूरी दुनिया उनको उनके नाम से जानती है। तो इसलिए एक साधे सब सधे, सब साधे सब जाए। अगर आपको अपने विषय से प्रेम हो गया है, अपने विषय को अच्छे से समझते हैं, अगर आप अपने विषय के लिए दीवानगी की हद तक डेडिकेटेड हैं, तो निश्चित मान करके चलिए कि आपका सितारा बुलंद होगा और आने वाले समय में सभी आपके प्रति नतमस्तक होंगे। हमारे सामने दुनिया के बड़े बड़े अच्छे प्रोफेसर आए हुए हैं, उनसे हमें मोटिवेशन लेना है। और एक बात, एक समय था आज से 40 साल 50 साल पहले जब भाषा एक बड़ी बैरियर हुआ करती थी, मगर आज वो सारी चीजें खत्म हो गई। कहीं से कोई प्रॉब्लम नहीं है, आप किसी भी लैंग्वेज के हो, कहीं से भी आ रहे हो, समस्या नहीं है। आप भारतवर्ष में ही 250-300 बोलियां बोली जाती हैं, डायलेक्ट्स हैं। लैंग्वेजेस देखा जाए तो अभी 12 + 10 मिलाकर 13 + 10 मिलाकर 23 भाषाएं तो ऑलरेडी हमारे फ्लो में आ ही गई हैं। मैथिली को भी शामिल कर लिया गया, और भी नहीं है। ज्ञान जो है वो कोई सीमा नहीं जानता। ज्ञान किसी जात धर्म को नहीं जानता, रंग को नहीं जानता, ज्ञान किसी प्रकार के भी डिस्क्रिमिनेशन को नहीं जानता। ज्ञान तो ज्ञान है। एकलव्य ने सोचा कि करना है तो गुरु द्रोण का उसने स्मरण किया और वो दुनिया का श्रेष्ठतम किया। ऐसे अनेक लोग हैं जो अपने गुरुओं को एक आराध्य के रूप में देखते हैं और आगे बढ़ते चले जाते हैं। चाहे वो भास्कराचार्य की बात कर ले, चाहे अनेक प्रकार के हमारे ने जो प्रदान किया है वो बहुत है, मगर वहां पर हमें कहीं ना कहीं आत्म करने की आवश्यकता नहीं है। हम बार बार वही शून्य और दशमलव करते रहते हैं, मगर उसके आगे क्या, वो सदियों पहले हजारों में क्या कर रहे हैं, इन चीजों पर अगर ध्यान देंगे तो मुझे लगता है कि भारतवर्ष सही गुरु बनेगा। केवल रोटी कपड़ा और मकान से जीवन नहीं चलता है। जीवन में आपको जितना, उससे कहीं ज्यादा ईश्वर आपको दे रहा है। अगर आपने इस मौके को इतने सारे विद्वान लोग बैठे, मैं रोल कॉल परेड में एक AK सिंह, पता नहीं उनको निश्चित रूप से मुझे नहीं याद करते, क्योंकि सैकड़ों बच्चे थे रोल कॉल परेड में। मैं 10वीं कक्षा में था और 10वीं कक्षा में जब रोल कॉल परेड होता था तो कोई न कोई एक अच्छी बात आती थी। तो हमारे एक जो कमांडिंग ऑफिसर हमारे जो सीईओ थे AK सिंह सर, तो AK सिंह सर ने एक बात कही कि बेटा ये चीज को अगर तुम क्या समझते हैं, अचरा समझते हैं, अचरा क्या होता है, कौन समझता है अचरा क्या होता है, आप जान रहे हैं? हाँ, पल्लू होता है, वहां कोने में माँ जो है ना कुछ पैसे बांध के रखती, बड़े अच्छे से गांठ बांधती है, वो नहीं है पैसे उसमें से। मैंने भी गांठ बांध ली, मेरे पास अचरा नहीं था मगर दिल में गांठ बांध ली। वो AK सिंह की बात आज तक मुझे नहीं मिली, उस बात ने मुझे यहां तक पहुंचाया। उनको भी नहीं पता कि मैं, वो मुझे प्रेरित कर रहे हैं। यहां पर इतने सारे अच्छे बोलने वाले हैं, कौन आपको आपके दिल को छू जाएगा, कौन आपकी आत्मा को झिझोड़ जाएगा, ये नहीं पता है। गणित या कोई भी विषय मैं बता रहा हूं, अगर आप काम करिए तो ऐसी काम करिए कि दुनिया आपको मिसाल दे, दाद दे आपको। एवरेज काम या तो ढंग से काम करो, बेहतरीन काम करो, ऐसा काम करो कि लोग कहें कि यार काम करना है तो इसके जैसा करो, वरना मत करो, खत्म कर दो, छोड़ दो। बहुत लंबी चौड़ी करते कहते मुद्दा करिए, डोंट वेस्ट इससे आपका नाम आने वाले समय में सारे लोग याद करेंगे। इसी के साथ मैं आप सभी लोगों को ढेर सारी शुभकामनाएं देता हूं। भाषणबाजी करना एक अलग बात है, बट आई ऑलवेज स्पीक आउट माय हार्ट एंड आई फील यू आर टेकिंग माय वर्ड्स very seriously and will be certainly motivated by that. And if one single student is getting motivated, I think my speech will be worth. Thank you very much.
Thank you so much, sir. Your remarks have been highlight of our event, and we are so grateful to have you with us. Now, we would like to request Professor A.K. Thakur, sir, to present memento to Honorable Professor Alok Kumar Chakrawal, sir.
And then we would request Dr. Uma Devi Patel ma'am to present memento to Honorable Professor Nilambari Dave ma'am.
Following this, we would request Dr. J.P. Jaiswal, sir, to present memento to Registrar of our University, Professor A. Randive, sir.
And then we would request Dr. B.B. Chaturvedi, sir, to present memento to Dean of Mathematical and Computational Sciences, Professor P.P. Murthy, sir.
In this series, we would like to request Dr. Santosh Verma, sir, to present memento to Head of Mathematics Department, Professor A.K. Thakur, sir.
And we would request Dr. Bijendra Paswan, sir, to present memento to Organizing Secretary, Dr. Kankan Sarkar, sir.
Now, we would like to invite Organizing Secretary of this international seminar, Dr. Kankan Sarkar, sir, for vote of thanks.
Namaskar. Good afternoon, everyone, the dais and the participants and the faculty members. On behalf of the organizing committee, it's my privilege to extend my heartfelt gratitude to all of you for being part of this international seminar. This inauguration session wouldn't have been successful without your valuable participation and support. First and foremost, I would like to thank Professor Nilambari Dave Madam, former Vice Chancellor, Saurashtra University, for accepting our invitation and sharing her inside knowledge and experience with us. Your presence and blessings have greatly enriched our seminar, Madam. I would like to thank our Honorable Vice Chancellor, Sir, Professor Alok Kumar Chakrawal, Sir. We are privileged to work under your visionary leadership and guidance. Thank you, sir. Thank you for graciously fulfilling all our demand which we needed to organize this seminar and ensuring all successful conduction of this international seminar. I sincerely thank Professor A.S. Ranadve sir for his valuable support to conduct the seminar, and we feel fortunate to benefit from you as you are also from our department, sir. I'd like to thank our Dean, sir, Professor P.P. Murthy, sir, for his valuable support and presence at the seminar. I also thank all the deans of different school and the heads of different departments and all other faculty members and students for joining us and making this event successful. Heartful thank to our distinguished speakers for accepting our invitations, and they will enlighten us throughout the various sessions. I would also like to express our sincere appreciation to all the participants who have actively engaged in this international seminar. Your enthusiasm and contribution have added immense value to our seminar. A special thanks to our sponsors of this seminar. First of all, our Guru Siddhas Viswavidhalaya, then Chhattisgarh Council of Science and Technology, HDFC Banks, Bank of Baroda, Bank of India, Punjab National Bank. Their support has made this international seminar possible. I would like to take this opportunity to acknowledge the tireless effort of our all faculty members, non-teaching staff, research scholar, and UG and PG students. This seminar would not have been possible without their hard work, coordination, and dedication. Thank you, your commitment to ensuring everything went smoothly. I thank our IT cell for smooth webcasting of the seminar. As this is a hybrid mode, around 60 participants have joined with us through online mode. I'd also like to thank Professor A.K. Saxena, sir, Director IQAC, Director R&D Cell, and our Finance Officer to conduct their seminar. I thank all the personnel who are directly or indirectly involved organizing this seminar. I thank you all for making this event successful. Now I request you all to join our group photo session after this inaugural session, and then we'll have a high tea break. I warmly invite you all to join with us. Thank you. Thank you very much.
Hello. Hello. All are requested for the lunch. Lunch कहाँ पर है? International guest house. The lunch is arranged in the international guest house. So all of you are requested to proceed for the international guest house for the lunch. Please. Thank you. Everyone, whether it is a participant, alumni, everyone has to go to the international guest house for lunch. After that, we will have the alumni meet for 30 minutes. So please, we have to first have the lunch and then we will have the alumni meet here.
आप सारे स्टूडेंट से निवेदन है कि आप सभी लंच के लिए गेस्ट हाउस में आमंत्रित हैं, ठीक है? जो एलुमनाइज है वो भी, पार्टिसिपेंट्स हैं वो भी। उसके बाद एलुमनाई का प्रोग्राम स्टार्ट किया जाएगा ओनली फॉर 30 मिनट्स इन द सेम प्लेस।
अनोखी थी वो दुनिया, अनोखे थे वो यार, एक एक कर बिछड़ गए जो थे सब कभी हमारे परिवार। आज फिर से मिलने को दिल रहता होगा बेकरार, अपनों का संगम रख जिजियों ने दिया है हमें यह अनुपम उपहार। आज उन लम्हों में खो जाओ सब, जिनकी यादें हैं दिल में हजार। आते रहो इस बगिया में ताकि यहाँ हो अनंत बहार। आज के इस अद्भुत मिलन पर हम सब करते हैं आप सबका सत्कार, आप सबका सत्कार।
A very good afternoon and warm welcome to our esteemed professors, distinguished guests on our Alma Mater's alumni meet. I am Maithili Tiwari from MSc Mathematics 3rd semester.
And I am Pushprata Thakur from MSc Mathematics 3rd semester. Dear alumni, it's an honor to have you back on campus. It's pleasure to see so many familiar faces and to welcome you back to the place where it all began.
No distance can break the bond we share as alumni. We welcome you all to Alumni Meet 2024, Department of Mathematics, Guru Ghashidas Viswavidyalaya.
Walking through these corridors, I'm sure many of you are feeling a sense of nostalgia. The classrooms, the canteen, the playground, the library, everything looks so similar yet different.
As we reunite, let's remember that the bonds are stronger than time and distance. The friendships that forged here will last a lifetime. Let's nurture them. Today we celebrate not only past but also future together.
Before moving ahead, now we gather to worship Goddess Saraswati, the embodiment of knowledge, wisdom, and creativity. As we light the lamp, we invoke the divine presence of Goddess Saraswati.
As it is said, Saraswati Mahabhage Vidya Kamal Lochne Vidya Rupe Vidya Lakshi Vidyam Dehi Namostute.
Next, to honor our guest, I would like to invite Dr. Manish Kumar Gupta sir to honor Registrar of our university and President of GGV Alumni Association, Professor S. Randive sir, with bouquet.
Afterwards, I would like to invite Dr. Koti and B.V. Varaprasad sir to present bouquet to Nodal Officer GGV Alumni Association, Dr. Manish Srivastav sir.
Subsequently, I would like to invite Dr. Dhananjay Gopal sir to honor our special guest, retired Professor SPC sir from Department of Mathematics, Guru Ghasidas Vishwavidyalaya.
Thereafter, I would like to invite Dr. Kankan Sarkar sir to honor with bouquet to Head of Mathematics Department, Professor A.K. Thakur sir. Following this, I would like to invite Dr. Amar Pandey sir to honor Departmental Alumni Coordinator Dr. Uma Devi Patel ma'am with bouquet. Now we would like to invite Head of Mathematics Department, Professor A.K. Thakur, sir. Gopal. Now we would like to invite Head of Mathematics Department, Professor A.K. Thakur, sir, for welcome address. Sir, welcome address.
Good afternoon, dear alumni, faculty members, and dear students. It is distinct pleasure to welcome all you. Wonderful occasion of alumni meet of the Department of Mathematics. Today is the celebration ensured bond between our alumni students and our department to fulfill the heart and pride to see many families and faces as well as a new ones gather here today. Our alumni of the rich history and bright future of the department over the year. You have contributed to our success in countless ways from the academic achievement of the valuable experience you have brought the professions you have true the treatment and quality of education community and values forever of our department. And this event is not just a reunion, but the opportunity to recollect the experience and inspire the next generation students. We are eager to hear your stories, learn about your journey since leaving the department, and discover how we can continue the foster and relationship between the benefits both you and our current students. On behalf of the entire Department of Mathematics, we want to express our heartfelt gratitude for the role you have played and shaping the future of academic community. Let's make rejoin memorable and filled with the laughter and shape the continuity of the learning. Welcome you again, and I look forward to enrich experience together. Thank you. Thank you very much.
Thank you, sir. Then I warmly invite our President, GGV Alumni Association and senior most faculty member of Mathematics Department, Professor A.S. Randive, sir, to share his wisdom.
गुड आफ्टरनून टू एवरीवन। अब मैं हिंदी में बोलना ज़्यादा पसंद करूंगा। सर, आप हिंदी समझ सकते हैं? धन्यवाद। मैं महसूस कर रहा हूं कि जब मैं यहाँ डायस पे खड़ा हूं तो आई एम स्टैंडिंग हियर इन द डिफरेंट रोल्स, 3 roles आई एम प्लेइंग साइमल्टेनियसली। अभी मैडम हमारी छात्रा, सॉरी क्या नाम बेटा, संबोधन में मैथिली ने जो कुछ शब्द कहे लीगेसी, और अब मैं उसको लीगेसी के साथ किसी और चीज से भी जोड़ना चाहूंगा, भारतीय संस्कारों की अनुभूतियां। प्रोफेसर एसपी सिंह मेरे पीएचडी गाइड रहे हैं। मैंने आपके साथ पीएचडी की है और मैं उनको सर्वप्रथम पीएचडी गाइड के रूप में उनका आभार व्यक्त करना चाहूँगा, उनको धन्यवाद देना चाहूँगा। मंच पर आज वो उपस्थित हैं, हम सभी उनके उपस्थिति से सम्मानित हैं। कुछ अन्य चीज़ें भी चल रही हैं जिसके बारे में प्रोफेसर मनीष श्रीवास्तव बोलें तो ज़्यादा बेहतर होगा। कुछ लीगेसी की बातें उन्होंने भी कही, सो ये मुद्दा मैं उन्हीं के ऊपर छोड़ रहा हूँ। मंचस्थ प्रोफेसर ए.के. ठाकुर, डॉक्टर धनंजय गोपाल, डॉक्टर उमा और मंच के सम्मुख विराजमान एक्सपर्ट जो इज ए मस्ट कॉन्फ्रेंस में अटेंड देने आए हैं। ISAMST, इज को अलग कर लें, ए को अलग कर लें, MST मस्ट, is a must. Thanks for coming over here on this occasion and allowing us and giving us a platform to arrange this alumni meet also in this short tenure of 2 days conference. मिश्रित अनुभूतियां हैं क्योंकि मैं जहां मंच पर मेरे अध्यापक उपस्थित हैं, मंच पर ही मेरे छात्र उपस्थित हैं और मंच के सम्मुख भी मेरे कुछ छात्र उपस्थित हैं। कंट्रीब्यूशन टू द सोसाइटी आप दे रहे हैं, ये मैं महसूस करता हूं कि आप सभी अपनी अपनी जगहों पर खड़े होकर कंट्रीब्यूशन टू द सोसाइटी दे रहे हैं। एक जो लीगेसी की पुनः बात करें तो मैं बात दोहराना चाहूंगा कि कुछ विभिन्न प्रकार के कर्ज कहे जाते हैं, जिसमें सर्वप्रथम है मातृ ऋण, माँ का कर्जा, जिससे आप उऋण नहीं हो सकते, जिसे आप चुका नहीं सकते हैं। वो आप इस जन्म में आपने जो जिस माता से जन्म लिया है उसके प्रति आप इस जन्म में ऋणी रहेंगे। पिता का कर्जा, पिता का ऋण, उसका कुछ अंश हम चुका सकते हैं पिता की सेवा करके, और अपने संतानों को एक योग्य जिम्मेदार नागरिक और उनके जीवन यापन के लिए आत्मनिर्भर बनाने के लिए एक दूसरा हिस्सा आप चुका सकते हैं। एक और कर्ज है गुरु का कर्ज। अब चूंकि लीगेसी बदल गई है, गुरु नहीं है, पेड टीचर्स हैं, तब भी एलुमनाई मीट या इस प्रकार की चीजें होती हैं जो आपको पुनः एक बार अवसर देती हैं कि जब आप अपने जीवन में स्थापित हो चुके हैं तो अपनी संस्था, अपने अध्यापकों के प्रति अपना आभार व्यक्त करें, उन्हें कभी मिलकर धन्यवाद ज्ञापित करें। जब मैं यह शब्द कह रहा हूं तो मैं एक और एलुमनाई मीट की कोशिश में लगा हुआ हूं। मैंने 1975 यानी 1975 में कक्षा 8 पास की थी। मेरी इच्छा है कि 50 वर्ष होने की स्थिति में मैं उस स्कूल जाऊं जहां मैंने कक्षा 8 उत्तीर्ण की है और वहां के अध्यापकों को कोई सरप्राइज दूं। प्लान्ड विजिट नहीं चाह रहा हूं मैं। लेट अस होप फॉर गुड। मैंने कुछ छात्रों को इकट्ठा किया है क्योंकि अब आप समझ सकते हैं, जो अभी मॉडर्न टेक्नोलॉजी के हैं वो नहीं समझ पाएंगे। जो मेरे समक्ष सीनियर टीचर्स बैठे हुए हैं वो शायद समझ सकेंगे कि 1975 के बाद आपके पास संपर्क का कोई तरीका नहीं है। 78 तक आप साथ थे, 75 से 78 में भी बिछड़ गए क्योंकि कुछ ने दूसरा विषय ले लिया, हमने मैथमेटिक्स लिया, उन्होंने दूसरा, और जीवन की राहें अलग अलग हो चुकी हैं और उसके बाद मिलना संभव नहीं होता। डॉक्टर दीवान यहाँ बैठे हुए हैं समक्ष, उनके ताऊ जी ना मेरे भाटापारा में कलीग रहे हैं, और अभी दीवान सर तो मैं कह रहा हूँ, लेकिन अभी जब थोड़ी देर पहले ही मैं बात कर रहा था, अरे मैं तुमसे बहुत नाराज हूँ और तुम चाचा को बोलो तुम्हारे कि हम तुम्हारे साथ खाना भी नहीं खाएंगे। तुम तो आ जाओ, चलो हमारे साथ बैठ जाओ, तुमसे क्या झगड़ा है। दिस इज द बॉन्ड ऑफ लव, बॉन्ड ऑफ अफेक्शन। जो कर्जे की चर्चा में कर रहा था वो चौथा कर्ज यह है जो समाज का कर्जा है, which you have borrowed from the society and in turn then you have to give it back to the society. उसमें राष्ट्रीयवाद डाल दिया जाए तो फिर यह है कि राष्ट्र के प्रति आपका समर्पण, क्योंकि आपके अध्यापकों ने, आपके माता पिता ने पूरे समर्पण के साथ आपको एक अवसर दिया। आपका यह दायित्व बनता है कि उसी समर्पण के साथ आप आगामी पीढ़ी को अवसर भी प्रदान करें और समाज के कर्ज को उतारने का भी प्रयास करें। समाज का कर्ज लगातार आप लेते हैं और देते हैं, एक हाथ से लिया जाता है, एक हाथ से दिया जाता है, और उसका कोई अकाउंट रखना संभव नहीं है। और अपर हैंड यह है कि आप जितना दे सकते हैं उतना दें, चाहे वह इस प्रकार की एलुमनी मीट में अपनी केवल उपस्थिति ही क्यों ना हो। आप लोग शायद, आई एम सॉरी, सामने यद्यपि मेरे कुछ सीनियर्स बैठे हैं, लेकिन मंचस्थ जो सीनियर हैं और प्रोफेसर एसपी सिंह विशेष तौर पे मैं उनके साथ चर्चा करना चाहूंगा कि आपका पुराना छात्र कभी भीड़ में से आकर आपका अभिवादन करे कि सर आपने मुझे इस सत्र में पढ़ाया है, उससे बढ़कर शायद उपलब्धि कोई नहीं है। उनकी उपहारों की कोई अपेक्षा नहीं है, दे डू नॉट एक्सपेक्ट एनी गिफ्ट फ्रॉम यू, बट द ओनली थिंग विच वी कैन ऑफर देम इज द रिस्पेक्ट। तो यह भी एक तरीका है, एलुमनी मीट, उसका नाम आधुनिक हो गया, लेकिन अगर हम अपने लीगेसी से जोड़ें, लीगेसी की चर्चा कुछ की गई, लीगेसी से अगर हम जोड़े तो ये चर्चा वहां तक जाती है। मुझे इस यूनिवर्सिटी की एलुमनी का प्रेसिडेंट माननीय कुलपति महोदय द्वारा नियुक्त किया गया है, मैं चयनित प्रेसिडेंट नहीं हूं। मेकशिफ्ट अरेंजमेंट्स होती हैं या कई अन्य चीजें होती हैं, क्योंकि एलुमनी एसोसिएशन एक सुदृढ़ रूप नहीं ले पा रहा, तो अभी काम चलाऊ सरकार के माध्यम से कार्य किए जा रहे हैं। तो इस काम चलाऊ सरकार में अध्यक्ष का दायित्व मैं निभा रहा हूं, सचिव का दायित्व डॉक्टर मनीष श्रीवास्तव बैठे हैं मंच पर, वो निभा रहे हैं। उम्मीद करते हैं कि एलुमनी एसोसिएशन का कंट्रीब्यूशन तो बढ़ेगा, लेकिन कंट्रीब्यूशन फाइनेंशियली ही नहीं, अपनी उपस्थिति और अपने एक्टिव पार्टिसिपेशन के साथ अब यह जिम्मेदारी हमारे कंधे पर आ जाए, हम इसे निभाने में सक्षम हैं। लीगेसी की बात हो रही है तो रघुरमन का मैनेजमेंट फंडा में पढ़ता हूं। ही इज ग्रेजुएट फ्रॉम IIM Ahmedabad. He did his BTech also from IIT. Such a intelligent person, and if you read him in दैनिक भास्कर, I'm not going for agency, ये मत कह दीजिएगा कि सर एजेंट है कि आप दैनिक भास्कर के, मुझे उसमें वो लेख देखने को मिलता है, इसलिए मैं उस लेख से संबंधित चीजों के बारे में करना चाहूंगा चर्चा। उसने उस लेख में अपने आप को कोट किया है, अपने पिता को कोट किया है, और मैं इस रेफरेंस में आपके साथ ये चर्चा लेना चाह रहा हूं कि लीगेसी की जब चर्चा हो रही है, एक भारत वह था, सुबह मैंने आपके साथ चर्चा की थी कि जब विश्वविद्यालय शुरुआत हुआ और मैंने पहले दिन ज्वाइन किया था तो मेरी स्थिति क्या थी, मैं ही हेड ऑफ द डिपार्टमेंट था, मैं ही बाबू था, मैं ही चपरासी था, और वर्चुअली चपरासी का भी काम मेरे को करना पड़ा, क्योंकि टाइम टेबल का डिस्पैच चढ़ाना है, तो टाइम टेबल का डिस्पैच चढ़ाएंगे कैसे, टाइम टेबल नोटिस बोर्ड पे टांगेंगे कैसे, बोर्ड ऑफ स्टडीज में रखा जाना है, प्रकरण सिलेबस रखा जाना है, तो देगा कौन। आपने नोटशीट लिख लिया, आपने आवेदन लिख लिया, लेकिन ये डीन के कार्यालय में जाना है, डीन के कार्यालय से ये रजिस्ट्रार को जाना है। तो हमारे डीन जो है वो इंजीनियरिंग कॉलेज में हुआ करते थे, क्योंकि मैथमेटिक्स डिपार्टमेंट नहीं था, तो हम फिर अपनी गाड़ी से या साइकिल से इंजीनियरिंग कॉलेज जाते थे कि सर ये है, वो उसको थोड़ा सा फॉरवर्डिंग कर दीजिए, तो फॉरवर्ड करके वो कुल सचिव को आ जाता था, कुल सचिव फिर वापस हम यहाँ इंजीनियरिंग कॉलेज में यहाँ लौटते थे और वो डिस्पैच रजिस्टर बाकायदा प्रस्तुत करते थे। ये आपके समाज के प्रति दायित्व है। अब जब माता पिता के रूप में दायित्व समझने की बात आ रही, तो मैं मैनेजमेंट फंडा पर जाना चाहूंगा। उन्होंने अपने जीवन का जो अनुभव शेयर किया वो है कि उनके पिताजी को उन्होंने निवेदन किया कि पापा, पिताजी मुझे आज नौकरी की पहली तनख्वाह मिली है, तो उन्होंने कहा अच्छा ठीक है, मतलब समय के पहले कोई खुशी व्यक्त नहीं करना। सो कह दिया, अच्छा क्या करना है, तो सैलरी जाके तुम्हारी माताजी को दे दो, भगवान को धन्यवाद दो, नहा के भोजन करने हमारे पास साथ आ जाओ। पहला महीना बीत गया, दूसरा महीना बीत गया, 6 महीने तक जब उसने मौन रखा, तब उसके पिताजी ने कहा, अब मैं सोचता हूं कि तुम पर्याप्त जिम्मेदार हो चुके हो, अपने परिवार का खर्च उठाने के लिए। ये लीगेसी ट्रांसफर के भी अपने तरीके हैं। जो जनरेशन गैप होता है, एक जनरेशन यहाँ है मंचस्थ, एक जनरेशन सम्मुख है, बहुत अंतर है। लेकिन मैं यह उम्मीद करता हूं कि इन छोटी छोटी कथानकों और कहानियों के माध्यम से जीवन के जो गंभीर मैसेज हैं, उन संदेशों के प्रति हम जागरूकता बनाए रखेंगे। मैं प्रेसिडेंट के रूप में इस एलुमनाई मीट का पार्ट बनने के लिए विश्वविद्यालय को धन्यवाद ज्ञापित करता हूं, गणित विभाग को धन्यवाद ज्ञापित करता हूं, और कुलसचिव के रूप में इस मीट से कुछ बाहर सॉलिड आउटपुट्स आएंगे, यह उम्मीद करता हूं। मुझे आमंत्रित करने के लिए और सुनने के लिए बहुत बहुत आभार, धन्यवाद।
Thank you so much, sir. We are grateful for your presence and insightful speech. Now, I would like to invite Nodal Officer, GGB Alumni Association, Dr. Manish Srivastav, sir, from Computer Science and Engineering Department, to express few words.
हेलो, आप सभी को मेरा सादर नमस्कार। परम आदरणीय एसपी सिंह सर, मंचस्थ हम सबके आदरणीय रजिस्ट्रार साहब रणदीवे जी, विभाग अध्यक्ष ए ठाकुर जी, मूर्ति साहब, उमा पटेल, धनंजय। बात लेगेसी की चली, क्योंकि मैं बैठा था सर के बगल में, तो मैं बोला सर एक अचानक ही इधर लेगेसी बोली, इधर भी लेगेसी बन गई। एसपी सिंह सर बैठे हैं, गुरु जी, उनके शिष्य रणदीवे से, और रणदीवे के शिष्य धनंजय, तो लेगेसी चलते आ रही थी। तो लेगेसी आओ आओ, फिर उमा पटेल मैडम। अब मैं, क्योंकि समय कम है, डायरेक्ट काम में आता हूँ। आप यूनिवर्सिटी गुरु घासीदास विश्वविद्यालय के ऊपर देख रहे हैं नेक A++। ये नेक A++ दिलाने में विश्वविद्यालय के एलुमनियों का बहुत बड़ा योगदान है। योगदान कैसे है मैं बताना चाह रहा हूं। हम लोग जब अप्रैल में काम शुरू किए, तब यूनिवर्सिटी के एलुमनी के अकाउंट में कोई पैसा नहीं था, जीरो था, अकाउंट भी नहीं खुला था। और नेक का एक नियम है, 5 लाख होगा तो 2 नंबर, 25 लाख होगा तो 4 नंबर, 50 लाख होगा तो 6 या 8 नंबर था, और 1 करोड़ होगा तो पूरा 10 में 10 भी 4 के मल्टीप्लायर में मल्टीप्लाई हो जाता है, जो नेक से जुड़े होंगे। और आप मानेंगे, जिस दिन हम लोग बने नोडल ऑफिसर से अध्यक्ष बने, हम 6 महीने के ऊपर 1 करोड़ 17 लाख रुपए इकट्ठा कर लिए। तो मैं सबसे पहले तो आप सब एलुमनी को धन्यवाद देना चाहता हूं, है ना। और दूसरी चीज ये बोलना चाहता हूं, किसी भी संस्था का नाम, मैं टीचर हूं लेकिन टीचर से नहीं होता। आईआईटी में आप कोई टीचर की बात नहीं करते, आप बोलते आईआईटी का ये स्टूडेंट यहाँ पे है। तो किसी भी संस्था का नाम छात्रों से होता है, तो हमारे एलुमनी के ऊपर डिपेंड है कि विश्वविद्यालय का नाम कहाँ तक ले जाते हैं। और ये बताते हुए मुझे गर्व हो रहा है, सुप्रीम कोर्ट के जज धीरेन्द्र मिश्रा जी हमारे एलुमनी हैं, राजस्थान हाई कोर्ट के जज मनिंदर श्रीवास्तव जी हमारे एलुमनी हैं, चंडीगढ़ की कलेक्टर अनीता मिश्रा हमारी एलुमनी है, 3-4 आईएएस छत्तीसगढ़ में हमारी एलुमनी है, 2-3 मंत्री हमारे एलुमनी है, और विधायकों की तो संख्या नहीं है ना। और मैं सबसे पहले पैसे की बात की है ना। तो मैं चाहता हूं एलुमनी जो भी कंट्रीब्यूशन अपने संस्था से दे, जैसे सर बोले ना, पितृ ऋण रहता है, ये ऋण रहता है, तो छात्र ऋण भी रहता है तो मैं चाहता हूं कि आप थोड़ा बहुत संस्था के लिए प्रति कुछ उत्तरदायित्व होता है, जो भी हो, आपको 2%, 5% आप दें, तो उससे आपका जुड़ाव होगा। जैसे अभी मेरे दोस्त लोग बहुत सारे जिम जाते हैं, तो जो फ्री वाला जिम है वो जा नहीं पाते, जब पैसा दे देते तो फिर वहां जाना शुरू कर देते हैं। जब आप पैसा दे देंगे संस्था को, तो फिर आप देखना शुरू करेंगे कि आपका पैसे का सही उपयोग हो रहा है कि नहीं। तो आप पैसा तो आपसे मैं ये सहयोग की अपेक्षा करता हूं। दूसरी बात मैं बोल रहा हूँ, ठीक है आप पैसा नहीं दे सकते, क्योंकि टीचर लोग के पास ऊपरी कमाई का कोई साधन रहता नहीं, ये नहीं, मैं कह रहा हूँ जैसे आप कॉन्फ्रेंस में आए, बिना कॉन्फ्रेंस में भी आके बच्चों को बता तो सकते हैं अभी क्या रिसर्च चल रहा है, आप इस एरिया में काम कीजिए। जैसे मैं मैथमेटिक्स से तो जुड़ा नहीं हूँ, लेकिन एक पार्टीशन थ्योरी, नंबर को पार्टीशन करने की, कंप्यूटर में हम लोग बहुत दिन से प्रोग्राम बनाने की कोशिश कर रहे हैं, बन नहीं रहा है। तो कुछ ऐसा आप उनको रिसर्च इन्वायरमेंट दे दें, आके जरूरी नहीं कि कॉन्फ्रेंस में ही आना है, कुछ नहीं तो आप बहुत सारे लोग नेट गेट क्वालिफाइड हैं, तो नेट की तैयारी कैसे, स्लेट की तैयारी कैसे, संस्था से आप जुड़े रहें, ये मैं आपसे रिक्वेस्ट करना चाहता हूँ। और आखिरी, क्योंकि रणधीर सर बोल रहे थे, तो मैं भी एक थोड़ा छोटी सी कहानी सुना के अपनी बात को विराम देना चाहता हूँ। दो दोस्त, एक बहुत मेहनती था, तो अपने दूसरे दोस्त से बोला, जिसका भाग साथ देता है उसका, तो दूसरा दोस्त बोला, नहीं गलत बोल रहे हो, जिसका राजा साथ देता है उसका भाग भी साथ देता है, उसको मान सम्मान पद प्रतिष्ठा सब मिलती है, जिसके साथ राजा रहेगा उसके साथ सब रहेंगे। दोनों में विवाद की स्थिति हो गई, बोले क्या किया जाए, बोले चलो राजा से ही पूछ लेते हैं कि कौन सही बोल रहा है। दोनों राजा के पास गए, तो राजा को बताया कि पहले वाला बोला मैं भाग बोल रहा हूँ, भाग साथ देता तो राजा साथ देता ही है। दूसरा वाला बताया सर मैं ऐसा बोल रहा हूँ कि इसका राजा साथ देता है, उसका भाग साथ देता है और सब। राजा को नेचुरली यही अच्छा लगना है कि जिसकी तारीफ होती है, तो राजा मन में तो सोचा ये ठीक बोला, इसको करना चाहिए, लेकिन जो उसका मंत्रिमंडल था वो बहुत प्रबुद्ध था, तो बोला अभी बोल दूंगा तो मुश्किल जाएगा, तो बोले मैं डिसीजन नहीं दे रहा हूँ, मैं तुमको एक एक गिफ्ट दे रहा हूँ, एक एक पोटली गिफ्ट दिया दोनों की, बोला ले जाओ यहां मत खोलना, 1 महीने बाद आना, फिर मैं आपको उत्तर दूंगा। दोनों को पोटली ले गए, थोड़े दूर गए, 1 आध किलोमीटर, दोनों पोटली खोले, तो जो बोल रहा था कि भाग साथ देता तो राजा, उसकी पोटली में सत्तू था, और जो बोला जो राजा साथ देता उसको सब, उसके पोटली में कुम्हड़ा था बड़ा सा। समझ में नहीं आया, तो बोले कुम्हड़ा लेके कहाँ तक जाऊंगा, जो राजा को बोला, बोले काम कर कुम्हड़ा को तू रख ले और मेरे को भूख भी लगी, सत्तू दे दे। तो पहला वाला उसको सत्तू दे दिया, कुम्हड़ा इसको दे दिया। वो लाद के कुम्हड़ा जब घर लाया तो कुम्हड़ा को काट के देखा तो उसके अंदर राजा ने हीरा जवाहरात भर के उसको दे दिया था। तो फिर हीरा जवाहरात भाग जो बोल रहा था उसके साथ आ गया। तो जो कर्म करता है, आज का कर्म ही कल का भाग निर्माण करता है। तो मैं आज आपसे कर्म करना चाहता हूं कि आप आए हैं, कुछ ऐसा करके जाएं कि हमारी यूनिवर्सिटी का भाग और ऊपर जाए और हम लोग देश में हमारे संस्था का नाम हो। धन्यवाद।
Thank you so much, sir, for informative speech. Now, I would like to invite our special guest, retired Professor SPC, sir, to share his valuable insights with us all.
Respected Ranadhir Saab, Registrar of this University, Professor Manish Srivastav, the coordinator of this alumni meet, Dr. A.K. Thakur, Professor and Departmental Alumni of this University, Dr. Dhananjay Gopal, Dr. Uma Devi Patel, Professor P.P. Murthy Saab, Dean of the Science Faculty, Mathematical and Computational Sciences, हमारे सभी सहयोगी भाई, बाहर से आए हुए मेहमान, डियर एलुमनाई ऑफ मैथमेटिक्स डिपार्टमेंट, पवन श्रीवास, द ओल्डेस्ट सर्वर इन द मैथमेटिक्स डिपार्टमेंट, बत्रा जी, द ऑफिस सुपरिंटेंडेंट इन मैथमेटिक्स डिपार्टमेंट। मैं कहाँ से शुरू करूँ, कहाँ से अंत करूँ, ये मैं नहीं समझ पा रहा। मैं इस विश्वविद्यालय में 1989 में ज्वाइन किया था, जुलाई 1989 में। रणधीर साहब हमसे 4-5 महीना पहले आ गए थे। 2 आदमी थे हम मात्र, गणित विभाग में मात्र 2 आदमी, और तमाम 25-25, 30-30 लड़कों का बैच एमफिल में चलता था। तिवारी जी उस समय थे, डॉक्टर DN तिवारी कुलपति, और करीब-करीब सारे लड़के उस समय जो निकले, वो सब लगातार 4-5 साल तक सब वेल प्लेस्ड हैं छत्तीसगढ़ में। कोई महाविद्यालय में है, तो कोई विद्यालय में है, हायर सेकेंडरी या इंटर में 10th में सब हैं, लेक्चरर या टीचिंग मैथमेटिक्स ही कर रहे हैं। और 4-5 तो प्रोफेसर हैं, जिसमें सामने अरविंद सिन्हा जी हैं, डॉक्टर रणधीर साहब हैं, डॉक्टर गोपाल, उमा देवी पटेल स्टूडेंट ऑफ डॉक्टर मूर्ति, फिजिक्स में प्रोफेसर हम खाली बता रहे हैं यूनिवर्सिटी में, अनुभा ठाकुर इन रविशंकर यूनिवर्सिटी रायपुर, एंड नमिता ब्रह्मे इन फिजिक्स डिपार्टमेंट, मनीष श्रीवास्तव in computer science and IT. He was earlier in science faculty of department of computer science. उसके बाद तमाम हमारे सामने, मैं नाम लेते लेते थक जाऊंगा, सब यहीं के अलुमनाई है। और हम लोगों ने, माने गणित विभाग ने अपनी पूरी जागरूकता के साथ छत्तीसगढ़ में प्रचार प्रसार किया है मैथमेटिक्स का। माने जहाँ कहीं भी जाते हैं, इसी में बहुत से लोग मिल गए, सर हमको आप पहचान रहे। निश्चित है कि टीचर आता है, पढ़ाता है, बोर्ड पर लिखता है, फिर चला जाता है, बच्चे इम्तिहान दे के डिग्री लेकर चले जाते हैं। तो जब वो रिकॉल करता है कि साहब हम इस बैच में थे, ये नाम था, तभी जानते हैं। डॉक्टर पंत अचानक मिल गए मुझको, नाम इनका हमको याद था, RP पंत साहब का। और हम एक हमारे मित्र हैं मिश्रा जी, वो हेड थे, हमारे साथ लेक्चरर थे गढ़वाल में। वहाँ से वो लाइबेरिया गए, अफ्रीका के डिफरेंट कंट्रीज में घूमते घूमते वो साउथ अफ्रीका पहुँच गए, और एक यूनिवर्सिटी में प्रोफेसर एंड हेड थे मैथमेटिक्स के। अभी नाउ इज लिविंग इन इलाहाबाद। प्राय चर्चा होती रहती, तो धनंजय गोपाल भी कभी किसी चीज में उनसे कांटेक्ट किए होंगे, वो हमको बता रहे थे टेलीफोन पर। और इतिहास बहुत लंबा चौड़ा है, लेकिन हम लोग अभाव में रहे। उस पुराने बैरक से मैथमेटिक्स की टीचिंग स्टार्ट हुई थी, और आते आते सेंट्रल की यात्रा भी कर ली। मैंने स्टेट यूनिवर्सिटी में 2 से 8 आदमी 7 आदमी हो गए थे, फिर सेंट्रल होते होते उनकी संख्या 14-15 हो गई, और बढ़ेगी ऐसा मुझे उम्मीद है, क्योंकि प्रोएक्टिव कुलपति जी हैं, और वास्तव में इन्होंने यूनिवर्सिटी को ऊपर उठाया है। कम से कम नाम तो है, क्यों अभी ये गए होंगे, हम भी बनारस जाते रहते हैं, काशी के रहने वाले हैं, तो बनारस गए तो BHU चले जाते हैं, तो यहाँ वहाँ डिपार्टमेंट में बहुत से लोग गए हुए हैं। वो तिर्की से भी मिला मैं, एक यहाँ तिर्की था ना, आप लोग नहीं जानते हो, वो मैकेनिकल इंजीनियरिंग में था, अभी वो प्रोफेसर हो गया है मैकेनिकल इंजीनियरिंग में। एक यहाँ थे राजपूत, नवीन राजपूत, वो भी वहाँ प्रोफेसर हैं BHU में, डिपार्टमेंट ऑफ इलेक्ट्रॉनिक्स में। उसके बाद भास्कर मुखर्जी गए यहाँ से, वो भी प्रोफेसर हैं BHU में। एक केमिस्ट्री में अनंत रमन या क्या नाम था उनका, नारायण, जो यहाँ रीडर थे, अब वहाँ गए वो, ऐसे अरे पतले पतले से थे केमिस्ट्री डिपार्टमेंट में, वो प्रोफेसर हैं। ये सब लोगों में मिलता रहता हूँ, मैं घूमता हूँ और सबका चाय पीता हूँ। और वास्तव में एक लेक्चर में ये पहुँच गए हम, चक्रवाल साहब, पंडित दीनदयाल उपाध्याय मेमोरियल पीठ है एक, वहाँ लेक्चर दिए। उनके कोऑर्डिनेटर बोले डॉक्टर साहब आपको बहुत तगड़े कुलपति मिले हैं। हमने कहा कैसे? कहा दिन भर यही सोचते रहते हैं, पढ़ाऊँ कैसे पढ़ाऊँ, क्यों अभी यंग एज है, तो अभी अपॉर्चुनिटीज भी ज़्यादा हैं, जैसा मैंने अगर ऊपर उठाए तो इनके आने के बाद ये सब एक्टिविटी बढ़ी है, मुझे इस बात की प्रसन्नता है। और आप सब लोग, सभी अलुमनी जो हैं और जो एक्सपर्ट्स हैं, सबका इस नवोदित केंद्रीय विश्वविद्यालय में स्वागत है। अगर आपको थोड़ा मोड़ा भी तकलीफ हो तो अच्छाइयों को यहाँ के लेके जाएं, और बुराइयों को एक छोटी नदी है अरपा, उसमें फेंक जाएं। तो मैंने जो भी लोगों ने इसको ऑर्गेनाइज किया है, उनसे वो सभी साधुवाद के पात्र हैं, और मेरी कामना है कि गणित विभाग निरंतर प्रगति करता रहे। तभी जब विश्वविद्यालय का नाम, विभाग का नाम होगा तो विश्वविद्यालय का नाम होगा, विश्वविद्यालय का नाम होगा तो बाहर आदमी अच्छे दृष्टि से देखेंगे, माने दृष्टि अच्छी होगी उनकी। वो यही उद्बोधन है मेरा एलुमनाई माने कि आप सब लोग विश्वविद्यालय के नाम को ऊंचा करने के लिए पठन पाठन में अवश्य जरूर ध्यान दें। रिसर्च तो सेकंड में आता है। प्राइमरी यूनिवर्सिटी 2 पर्पस से अपॉइंटमेंट करती है। सम अपॉइंटमेंट फॉर गुड टीचर, सम अपॉइंटमेंट फॉर गुड रजिस्टर माने रजिस्ट्रेशन गुड रिसर्चर। तो दोनों एक साथ नहीं हो सकती। माने गुड टीचिंग और गुड रिसर्च, रिसर्च में थोड़ा गिरावट होगी या फिर टीचिंग होगी, वही ध्यान घूमता रहेगा वहीं प्रॉब्लम पर, तो निश्चित है कि किताब नहीं ध्यान से पढ़ेंगे। पर हम अपना अनुभव बता रहे हैं। इसलिए गुड टीचिंग एंड गुड रिसर्च both makes the university up, and it is our fundamental duty to upgrade this university to the highest climate. इस उद्बोधन के साथ मैं सबको धन्यवाद देता हूं। जय हिंद, जय छत्तीसगढ़, जय भारत।
Thank you very much, sir, for your remarkable remarks. ये वक्त क्या है, ये क्या है आखिर कि जो निरंतर गुजर रहा है? ये जब न गुजरा था तब कहाँ था? कहीं तो होगा, गुजर गया है तो अब कहाँ है? कहीं तो होगा, कहाँ से आया किधर गया है? ये कब से कब तक का सिलसिला है? ये वक्त क्या है?
कभी कभी मैं ये सोचता हूँ कि चलती गाड़ी से पेड़ देखो तो ऐसा लगता है दूसरी ओर जा रहे हैं, मगर मगर हकीकत में पेड़ अपनी जगह खड़े हैं। तो क्या ये मुमकिन है सारी सदियां कतारबद्ध अपनी जगह खड़ी हों, ये वक्त खड़ा हो और हम ही गुजर रहे हों? इस एक लम्हे में सारे लम्हे तमाम सदियां छुपी हुई हों, जो हो चुका है, जो हो रहा है, जो होने वाला है। मैं सोचता हूँ कि क्या ये मुमकिन है? सच ये हो कि सफ़र में हम हैं, गुजरते हम हैं, जिसे समझते हैं हम गुजरता है वो थमा है, गुजरता है या थमा हुआ है, इकाई है या बटा हुआ है मुजमिद या पिघल रहा है, किसे खबर है, किसे पता है कि ये वक्त क्या है?
Now, I would kindly invite Professor S. Randive sir, Dr. Manish Srivastava sir, Professor SPC sir to honor our alumni for their dedication to their work and accomplishments.
We would like to invite Purushottam Rathore sir, Sujit Kumar Singh sir, सुरेखा देवांगन।
थोड़ा सा क्यू अप होके जल्दी आ जाए, कार्यक्रम को जल्दी समाप्त करें।
चांदनी छाप
लेते जाओ।
चांदनी छाबरा द्वा, आदर्श तिवारी, कामिनी सिंह, प्रांजल गुप्ता, विनायक पटेल, नेहेश चंद्रा, किरण पटेल, मेघा वर्मा, अमन मालाकर, अभिषेक पटेल, प्रदीप दास, आशीष कश्यप, चंदन साहू, साक्षी साहू, सयंती दत्त, महेंद्र सिदार, रुपेश साहू, नूतन सोमी, आदित्य सिंह ठाकुर, ओम प्रकाश राठौर, प्रज्ञा धृतलहरे, योगिता यादव, विजय कुमार दास, अंजलि कश्यप, आंचल सिंह, लेख राम देवांगन, नंदिता पटेल, प्रभावती भगत, ऋतिक कुमार देवांगन, दीपक कुमार टंडन, वेद प्रकाश पटेल, आदित्य सिंह। अब क्या है इसके बाद?
मैं बोल रही थी इसको बोलो कि क्या करूं, उसके बाद तो भी है बोलो थैंक्स आ जाएगा, तो इसको बोलना है कि क्या करना है, इसको तो Now, I would like to invite Dr. J.P. Jaswal sir to present memento to Professor SPC sir.
Now I would like to invite Dr. Manish Kumar Gupta sir to present memento to Manish Srivastav sir. I would like to invite Dr. B.B. Chaturvedi sir to present memento to Professor A.S. Randive sir. Thanks. Now we are delighted to invite Departmental Alumni Coordinator Dr. Uma Devi Patel ma'am to deliver the vote of thanks at our Alumni Meet program.
मैं डॉक्टर उमा देवी पटेल, असिस्टेंट प्रोफेसर डिपार्टमेंट ऑफ मैथमेटिक्स, एंड आई एम वर्किंग एज ए एलुमनाई कोऑर्डिनेटर ऑन डिपार्टमेंट ऑफ मैथमेटिक्स। यहाँ पर उपस्थित समस्त प्रबुद्धजनों से सबसे पहले मैं माफ़ी मांगना चाहूँगी। एक्चुअली हमारा ये प्रोग्राम थोड़ा सा रीशेड्यूल होकर लेट हो गया, तो आप हमें थोड़ा सा माफ़ करिएगा। आपको जो असहजता महसूस हुई है, और धन्यवाद ज्ञापन की श्रृंखला में सर्वप्रथम धन्यवाद ज्ञापन मैं रजिस्ट्रार महोदय प्रोफेसर A.S. रणदीवे सर का करना चाहूँगी, जिन्होंने अपने बहुत ही बिजी शेड्यूल में से हमें इतना सारा समय दिया और इस कार्यक्रम में उपस्थित होकर इस कार्यक्रम को सफल बनाया। थैंक यू सो मच सर। इसके पश्चात धन्यवाद ज्ञापन की अगली श्रृंखला में नोडल ऑफिसर एलुमिनी एसोसिएशन गुरु घासीदास विश्वविद्यालय सर डॉक्टर मनीष श्रीवास्तव सर का मैं बहुत बहुत धन्यवाद सर, आपने इस कार्यक्रम में शामिल होकर इस कार्यक्रम की गरिमा बढ़ाई। थैंक यू सो मच सर। इसके पश्चात रिटायर्ड प्रोफेसर एसपी सिंह सर, सर आपका भी बहुत बहुत धन्यवाद जो इतने कम समय में हमारा आमंत्रण स्वीकार किया और यहाँ उपस्थित हुए और इस कार्यक्रम की गरिमा बढ़ाकर हमें कृतार्थ किया। इसके पश्चात डीन स्कूल ऑफ मैथमेटिकल एंड कंप्यूटेशनल साइंसेस प्रोफेसर पीपी मूर्ति सर का भी बहुत बहुत धन्यवाद। हेड ऑफ द डिपार्टमेंट ऑफ मैथमेटिक्स प्रोफेसर ए के ठाकुर सर का भी बहुत बहुत धन्यवाद। डॉक्टर धनंजय गोपाल सर का भी बहुत बहुत धन्यवाद तथा यहाँ पर उपस्थित समस्त प्रबुद्ध जनों का भी बहुत बहुत धन्यवाद जिन्होंने हमारा यह कार्यक्रम देखा और हमें इसे सराहा। और not but the least all the alumni member those who are coming in a short notation and accepting our invitation and complete this program very successfully. Thank you so much. Thank you so much.
ओके, इसको हटाना है। चलो बेटा प्लीज वॉलंटियर।
So we are now going to start our invited lecture. So I request MM Singh, sir. I request Professor MM Singh, sir, to be in dais. Sir. And we also request our invited speaker, our Professor S. Randive, for the seat. नहीं ये तो ये बोल रहे हैं एक सेशन चेंज कर लेना ये
Okay. Thank you very much. Due to that, in the morning session, we was due to hurry of the time, we was unable to complete one more session. It was complete, but not fully completed of Arvind Kumar sir. So I hope if there is any question answer session, then participant can interact with him directly. But from our end, from the Department of Mathematics, we want to honor Arvind Sinha sir. So, Benita, ready? So, Arvind Sinha sir, please come forward. And I am also requesting Thakur sir to honor with a token of memento. Ankita, yeah, Charmita, photo. Okay, now okay, one more. Okay, one more eminent professor, Professor Devan sir is with us. So we also want to honor him from our department. So I am again requesting our HOD sir to honor Devan sir. Thank you very much, sir. Now, I am handing over this microphone to Professor M.M. Singh, sir, to continue this invited lecture. Sir.
Good afternoon, all participants and guests. I feel privileged to invite Professor Abhay Saran Randive of Mathematics Department, Senior Most Professor of Department and Registrar of this University also, for his lucid lecture. Dr. Randive has been a signature in the field of mathematics, particularly in the field of algebra, that I have come to know. And he has published a great number of papers in national international journals and seminars and national proceedings, international proceedings, and also guided several scholars, including my friend Arvind Sinha, for the award of PhD degree in mathematics. And so I am happy to invite him for his lucid lecture here.
थैंक यू सर। चूंकि मुझे बोलना मैथमेटिक्स पर है तो मिली जुली लैंग्वेज रखने का प्रयास करूंगा। और धन्यवाद है कि अभी वो छात्र नहीं है जो एमए, एमएससी और बीएससी में मुझसे पढ़ते हैं। कोई है तो नहीं भाई? चलिए, वो नहीं है तो थोड़ा सा अलग तरीका। कोशिश करता हूं कि मैं एक सिंसियर छात्र बना रहा हूं, लेकिन विश्वविद्यालय में पता नहीं क्यों मैं बहुत सारे कामों के लिए कभी जीवन में मना नहीं कर पाया। सो अभी जो दायित्व मैं निभा रहा हूं, उस दायित्व के तहत जब प्रोफेसर ठाकुर मेरे पास आए थे कि सर आप कुलसचिव भी हैं लेकिन विश्वविद्यालय में गणित विभाग के अध्यापक भी हैं, मैंने कहा हाँ। तो बोले सर एक टॉक आपका भी होना चाहिए, कंकण सरकार वाज आल्सो विथ हिम। तो मैंने कहा बोलने का तो मेरा बहुत मन है, लेकिन मैं अनियमित हो चुका हूँ और अनफॉर्चुनेटली मैथमेटिक्स में रेगुलरिटी एक स्टडी पॉइंट है, हम स्टडी करते हैं। तो आई एम वन ऑफ दोज हु आर रेगुलरली इरेगुलर। सो मुझे हर बार फोकस करना पड़ता है या कोई पकड़ के मेरा फोकस करवा देता है मैथमेटिक्स पर। मैथमेटिक्स मैंने कभी चाहा नहीं था कि मैं मैथमेटिक्स करूं। आई गॉट ओनली 17 मार्क्स आउट ऑफ 100 एंड 17 मार्क्स आउट ऑफ 100 मीन्स यू आर फेल स्टूडेंट। अब ठीक है, उसके बाद जो पिटाई कुटाई हुई, उसके बाद जो कुछ हुआ वो इतिहास है। सो कभी मेरे परिचितों में से और कुछ अन्य लोगों ने मुझे कहा यू आर नॉट इंटेलिजेंट, यू आर डिलीजेंट। जो कुछ आप प्राप्त कर रहे हैं वो आपकी मेहनत से प्राप्त कर रहे हैं। तो ऐसी परिस्थिति में ऐसा हो जाता है कि मुझे लगातार मेहनत करना पड़ती है, नंबर 1। और नंबर 2, मैं बहुत हायर लेवल पर जाकर नहीं बोल पाता हूँ। जब भी कभी मैं कोशिश करता हूँ तो मुझे लगता है कि अगर मैं 1-to-1 कोऑर्डिनेशन नहीं बैठा पा रहा हूँ और जो ऑडियंस मेरे समक्ष उपस्थित है, अगर वो मेरी बातों को आनंद नहीं ले रहा है, तो मैं यहाँ सिर्फ इसलिए उपस्थित नहीं हूँ कि मेरा रिसर्च पेपर ये है और उसका इम्पैक्ट ये है। इम्पैक्ट फैक्टर पढ़ने वाले वो ठीक है, पढ़ लीजिए, आप मिल जाएगा कहीं पे भी। Thank you. Thanks for encouraging me, sir. So, I will simply focus on few things. And unfortunately, yesterday I was free only after 10 o'clock, and yesterday my day started at 8 a.m. So from 8 a.m. till 10 p.m. I had to work non-stop for different capacities in the university. I could not absolutely prepare for the lecture. आज करूंगा, कल करूंगा, कल करूंगा, करते करते कल रात भी निकल गई और आज फिर ये स्थिति बन गई कि मेरे कार्यालय में मैं बैठा था तो मैंने कहा मुझे लेक्चर देना है। तो गुप्ता जी मेरे पुराने सहयोगी हैं और ऐसे संकट में वो तारणहार बनते हैं। मैंने कहा गुप्ता जी आपका मेल जरूर मेरे पास है, मैं मेल में कुछ पीपीटी भेज दे रहा हूँ भाई, उसको जरा वहां लगवा देना। सो परीक्षण मत लीजिए भाई, टेस्ट मत लीजिए मेरी उसी पेपर पीपीटी पर हम आ जाएं और शुरुआत करें। दरअसल ये पीपीटी या ये प्रेजेंटेशन का जो मेरा एम था उसको मैं सबसे पहले ऑडियंस के समक्ष शेयर करना चाहूँगा कि जो फजी लॉजिक अप्रोच है वो हम सभी जान रहे हैं कि फजी लॉजिक पर आधारित वॉशिंग मशीन्स और फजी लॉजिक बेस्ड एक्सेलरेटर जो आपके एलिवेटर्स बने हुए हैं, कहीं हाई राइजिंग टावर्स पे आप जाएं तो आपको ताज्जुब होगा कि जितनी तेजी से आप ग्राउंड फ्लोर से 100 फ्लोर पर पहुंच गए, आपको कोई जर्क नहीं लगा, कोई एक्सेलरेशन आपने महसूस नहीं किया, नाइदर यू फेल्ट एनी एक्सेलरेशन नॉट यू फेल्ट एनी डीएक्सेलरेशन। सो व्हाट इज दैट टेक्नोलॉजी? हम जहाँ छोटी मोटी लिफ्ट में बैठते हैं ना, तो जरा से लिफ्ट तेज होती है तो तुरंत पता पड़ता है, लिफ्ट नीचे आती है तो पता पड़ता है कि हम स्टेशन पॉइंट पे पहुंच चुके हैं। So how these things go on smoothly? What is the logic behind this, and how this logic differs from our classical logic, right from the origin of mathematics? Rather, I should say recorded origin of mathematics. The origin of mathematics तो हमारा भारतीयों का बहुत पुराना रहा है, लेकिन फिर से वो विवाद का विषय है कि भारतीयों ने अपनी ज्ञान परंपरा के तहत प्रूफ राइटिंग्स पर एम्फेसिस क्यों नहीं दिया।
बोधायन प्रमेय हमें पता है, वन ऑफ द एक्सपर्ट्स आई वाज रीडिंग, ही इज फ्रॉम वैदिक मैथमेटिक्स। सर आप हैं? सो बोधायन प्रमेय आपने ब्रह्मस्फुटी का उल्लेख किया है। बोधायन प्रमेय हम जान रहे हैं, हमारे पास ऐसे सैकड़ों प्रूफ मिल जाएंगे जहां हम कह सकते हैं कि भाई ये सब बोधायन प्रमेय के बिना हो ही नहीं सकता था। तो अब क्या कारण है कि बोधायन प्रमेय का प्रूफ आपके पास उपलब्ध नहीं है? आपके पास जितने भी ट्रिपलेट का डेरिवेशन है, वो डेरिवेशन है आज की तारीख में इंडियन क्लासिकल मैथमेटिक्स, इंडियन ट्रेडिशनल मैथमेटिक्स आपको बोधायन प्रमेय से रिलेटेड पाइथागोरियन ट्रिपलेट किसी भी गिवन नंबर के लिए जनरेट करना सिखा देते हैं। गिव यू जस्ट वन सीड एंड आई विल गिव यू, इफ यू गिव मी a and I will find out b and c in such a way that c square is equal to a square plus b square, but we have lost the proof. That is the issue. However, if we go for that classical logic and if we come up to the fuzzy logic, so I will just like to point out within few minutes or so that what is the basic difference, why is this lake is occurring, and what is the task in front of us. In my beginning of the career, I started doing algebra, and my first student was in algebra, as you sir said. Then I shifted to fuzzy algebra. I taught fuzzy topology also, and when I was learning and relearning all these topics, I could understand if you cannot find the application of mathematics, sometimes you are going to be thrown away in the dustbin. Okay, you are having your research papers, but if your research papers are not visiting nor not coming up to the demand of the society, it will be dumped on. So I switched over to some other ideas, and I started learning fuzzy state theory and fuzzy logic. And I tried my hand later on in this area, and recently I'm trying to do application of fuzzy logic in the area of graph theory also. So the origin comes from over there. Next slide, please. The topic is a little bit vivid. I'm talking about evidence theory, possibility theory, and fuzzy application in graph theory also. Let us go step by step, a little slow. I beg my pardon to those experts who are already knowing fuzzy set theory very nicely. So I'm over there, they may find that you are too much slow, but there maybe I expect some of the people will be there who are not knowing fuzzy set theory to that extent. So this is basically the idea when you say yes or no to an element belonging to a set. If an element belongs to the set, say yes. If it doesn't belong to the set, say no. But now the question arises, am I intelligent? Am I intelligent? Because I'm sitting on this dais, hardly anyone from you will be saying you are not intelligent. But everybody has a doubt. कि सर ठीक है, अब आप डायस पे खड़े हैं तो आप इंटेलिजेंट हैं, हम डायस पे नहीं हैं तो हम इंटेलिजेंट नहीं हैं। लेकिन ये ग्रे होना चाहिए, इंटेलिजेंसी की डिग्री होना चाहिए। I am neither intelligent nor in the category of non-intelligent. I am somewhere in between. So all real world problem are in between something. If we now talk it mathematically, it is an element, say 1, characteristic function, say 1, image is 1. If it is not, image is 0. Just widen this scope of two-ton set 0, 1 to an interval starting from 0 to 1 and keeping the same analogy, because you are moving for the generalization from the classical set theory to fuzzy set theory. You are moving, so you have generalized the characteristic function in the shape of what you call as fuzzy set over a set, right? So it gives you degree of membership. So my degree of intelligence can be guessed. Okay, I will say I'm 0.6. I have a degree of intelligence of 0.6. Possibly I will not get that much of resistance. And if I talk about Ramanujan and I say his degree of intelligence is 1, once again I will not get any resistance. But if I say something else, then it may create some resistance. So this is the acceptability of the society. Now the thing Einstein observed a long back is this one, that mathematics is too much rigid. And in 1935, Max Planck observed that this logic which you are talking about, two-valued logic, yes and no, implication, one rule only. this is something too much rigid, and because of this rigidity in mathematics, mathematics falls to be under the category of applicable sciences. It becomes queen of science, no doubt. It remains queen of science. It remains everywhere behind any idea whatsoever it comes. But what is the real application of mathematics? If you ask someone, then of course someone will go into differential equation, someone will go somewhere else, somewhere will go in induction and whatsoever. But real scenario pictures are coming less vivid, and the application of mathematics was earlier limited to certain branches of studies. So this deficit or deficiency of mathematics was very well observed by Max Planck. He tried to give three valued logic: 0, 1 and half in between. But that was not acceptable. Okay, sometimes say, oh, okay, what is the output of some antecedent and yeah, rather two antecedents and one consequent. Say P and Q implies R, P implies Q. What's you go for choosing up? So what will be the output if 0 and 1 output is your truth table you are forming is P is 0, Q is 1, P implies Q is still 1. What you will give for half? If you give it for half as 1, okay, you sound to be more logical, but you are not once again opening the window. The window is restricted. So this idea was transferred in 1965 by Lotfi-e-Zadeh into the idea, let us go for the wider sense of fuzzy logic, and wider sense of fuzzy logic includes infinite valued fuzzy logic. And why this infinite valued fuzzy logic is required, the idea comes basically from here. You said just now that a fuzzy set is a function from a non-empty set X to the interval, closed bounded interval 0, 1, then it's okay. How you define union of two such fuzzy sets? How do you define intersection of these two fuzzy sets? How you define their subsethood? And so many questions arise in this consequence. Just for the sake of development of mathematics and just for the sake of doing mathematics, you can define your union as maximum, minimum, intersection, and complement 1 minus. But once again, you will find that that is not once again a broader sense of mathematics, and therefore you sometimes come across what is the general definition for union of two fuzzy sets. So you go for sometimes some back T norms and T co-norms. Those who are doing fixed-point theory, they very well know it, probabilistic metric spaces. And they have used this function. But using this function into fuzzy set theory was a novice idea. And then came the results that you have infinitely many number of complements. And because you have infinitely many number of, I should say fuzzy complement, because you have infinitely many number of fuzzy complements, you are bound to have infinitely many unions and infinitely many intersection of fuzzy sets. So that is the wider range, that you choose the union which suits to you or your mathematical demand most best in a best way. That flexibility is occurred and offered by fuzzy logic if you go it for the wider sense. Now once again, from classical set theory we are differing because it's classical set theory and classical logic with two possible antecedents 0 and 1, and for two variables P and Q, the truth table for P implies Q can be drawn, and you can find out what is the implication output of P implies Q. Now once again, when you turn these ideas into fuzzy set theory, the four equivalent formulas, rather four tautologies to define P implies Q, once again give you infinitely many implication relations. That is once again the fun, and this flexibility once again gives you a larger domain to work on. Now, if you just focus on this aspect, it will carry forward your research in many directions. But because I said that better we sometimes focus ourselves on the application aspect also. So from that point of view, now I will like to have some another slide. Next, please. Next, please. Yeah, you may stay somewhere over here. I'm not going into the classical evidence theory. I'm simply coming up. Can you have the next slide, please? Because time is short, I should not take place. Next slide. Yeah, please stay over here. I'm just giving some glimpse of the certain ideas. For those who are novice to this topic or might have learned somewhere heard, but not have gone through it very seriously, evidence theory is one of the branch of mathematics, and this has given birth to so many different theories. Under evidence theory, you can sum up one theory which is termed as probability theory. Probability theory is the theory generated by experiential learning or through set theory. Experiential learning, if you toss up a coin, what you will get and what is its probability. If you call it as head and tail, then we now know it as 1 by 2. You derive it because outputs are 2 and 1 is my favorable. So number of possible events in the denominator and in the numerator favorable events, simple theory. But this can be derived by experience. And what is that method? You toss up 10 coins 1 times. Out of those 10 coins, you find out how many are heads and how many are tails. Repeat this experiment in 100 times, say. Note down the events, note down the outputs. Go on once again for another 100 set, once again for another hit. Now, when you take its limiting value, that will be half. Now, this is calculation method. You are approaching to half, and set theory gives you a simple, sir, one favorable output and total output 2. So simple mathematics say 1 by 2. So playing cards and probability theory you find out. But when it comes to geometrical probability, things go absurdly wrong. What is the probability that I draw 2 straight lines in a plane? I'm keeping it simple, not 3-dimensional. If I draw 2 straight lines in a plane, what is the probability they are parallel? Geometrical probability. Things become quite complicated one. So probability theory has its own limitation. This was later on discovered. But what is the agent of uncertainty? Next agent for uncertainty. And fuzzy set theory has put its claim as an agent for dealing uncertainty under a different way. And that branch of study, when we compare it with evidence theory, that takes you to possibility theory, right? Now, if you compare probability theory and possibility theory, you will find that certain portion of these two theories match each other, but still certain theories do not match with each other. And you have a tremendous scope of bringing this in single umbrella. Evidence theory has already done it, but the part which the probability theory is playing in our life is quite different from the part which the possibility theory can play. For an example, if we talk about something like एक घटना में मारपीट हो गई और मारपीट के बाद केस चल रहा है, तो मारपीट के बाद केस चल रहा है और जूरी सिस्टम है, मान लीजिए पुराने जमाने का। आप में से कई लोगों ने एक रुका हुआ फैसला देखा होगा, और मैं कई बार अपने छात्रों को कहता हूं कि अगर आपको फजी सेट थ्योरी पढ़ना है और फजी लॉजिक पढ़ना है तो एक रुका हुआ फैसला पिक्चर जरूर देखिएगा, एंड यू विल एंजॉय इट। द क्रक्स आई एम यूजिंग जस्ट क्रक्स ऑफ द स्टोरी, एक जूरी सिस्टम है और जूरी सिस्टम में कोई घटना हो गई है, इस पर्टिकुलर पिक्चर में ये घटना हो चुकी है कि किसी एक महिला ने जो कम देख पाती है, ट्रेन की खिड़की से कुछ देखा, जिसके अंतर्गत उसने इस आरोप की पुष्टि कर दी कि एक वृद्ध बुजुर्ग की उसके बेटे ने ही हत्या कर दी है। 10-12 लोगों की जूरी बैठकर निर्णय ले रही है और फर्स्ट डिसीजन टॉसअप होता है 1:11, 1 in favor of the boy and 11 against the boy, and then story really starts and goes into the deep, where you observe what is the human behavior and what is the difference between truth and fact. And then you discover, oh my god, somewhere here uncertainty is there everywhere, and if the jury has to take a firm decision, the decision should be firm without any doubt. So after, in the end of the story, when it goes for a last but one jury's decision, the things come in favor of 11-12. 11 in favor of the boy who was suspect of murder, and one only against him. And when we go into the deep of the story, we find that the person who was still against the boy has a prejudice against his own son. मतलब आपका पूर्वाग्रह आपको सत्य की जानकारी लेने से रोक रहा है। Here is the question कि प्रोबेबिलिटी थ्योरी भी हमारे मन में कहीं तो भी अनिश्चितता से डील करने के लिए एक गारंटेड ठेकेदार के रूप में उपस्थित है। और हम जब कभी भी मैथमेटिकल रिसर्च करते हैं और जब कभी न्यूमेरिकल डेटा एनालिसिस की बात करते हैं और कोई स्टैटिस्टिकल टूल अपनाना चाहते हैं, तो आप बिना सोचे समझे प्रोबेबिलिटी थ्योरी को चूज करते हैं। पॉसिबली इट इज नॉट करेक्ट, और इसका एक एविडेंस मैं देना चाहूंगा विदाउट अलोइंग मी एनी डिस्प्यूट। आई डू नॉट वांट टू रियली इंडल्ज इनटू एनी पॉलिटिकल डिस्प्यूट, लेकिन अभी लगातार आपको कई चुनावों में चुनाव के परिणाम को लेकर एक दावा सुनने को मिलता है कि एग्जिट पोल का नतीजा ये होगा, और नतीजा चौंकाने वाला होता है, वो एग्जिट पोल ही ध्वस्त हो जाते हैं। क्या हो रहा है? एक स्टेटिस्टिक्स को लेकर कहावत ही भी है ना, औसत ज्यों का त्यों कुनबा डूबा क्यों। पढ़ा होगा, सुना होगा आपने कि नाव नदी पार करनी है, स्टेटिस्टिशियन महोदय जो है वो एवरेज डेप्थ ऑफ द रिवर, एवरेज हाइट ऑफ द फैमिली लेके चल पड़े और नदी पार कर ली। उन्होंने पीछे जाके देखा तो पीछे तो कोई है ही नहीं, तो औसत जो खाते हो कुनबा डूबा के वो बैठ के सोच रहे परिवार कहाँ चला गया। यही हाल आपके इन जो प्रेडिक्शंस हैं इलेक्शन को लेकर वो हो रहे हैं कि आपका सैंपल प्लेस स्पेस गड़बड़ है, आपका कॉन्फिडेंस लेवल रीड करने का आप कोई साधन नहीं लगा रहे हैं। 5 लोग एक ही पक्ष में बोल रहे हैं तो छठा या तो चुप है या थोड़ा सा कुछ बोलने की कोशिश करता है। यू आर नॉट जजिंग हिम। सैंपल स्पेस इतना छोटा है और उसके ऊपर ये जो अनसर्टेनिटी का पार्ट है उसको आप कवर ही नहीं कर रहे हैं। संभव है आप में से कोई आगे इस मुद्दे को उठाना चाहे, क्योंकि लेट मी यूज द टूल फजी सेट थ्योरी, फजी लॉजिक, how I can use it. And when I was talking all these things, I said, no, talking is good enough. Can you really convert something into an application? So I started working on this type of idea कि फजी अलजेब्रा हो गया यार, फजी टोपोलॉजी पे भी रिसर्च पेपर हो गए, फजी अलजेब्रा पे भी पेपर हो जाएंगे। एप्लीकेशन ऑफ फजी लॉजिक पर हम आए और डिसीजन मेकिंग में क्या आप कुछ दे सकते हैं। जो पूर्वाग्रह वाला रोल है ना, वो रोल अभी भी आपको कष्ट दे रहा है, ये मैं अभी कहना चाह रहा हूँ। सो ए वेरी गुड पेपर ऑफ माय स्टूडेंट वाज कम्युनिकेटेड। यहाँ यूएसए से भी कोई एक्सपर्ट हैं पॉसिबली? शुक्र है यूएसए से है, चाइना से नहीं है, ताइवान से भी नहीं है। सो my student communicated this paper to some good journal, and the paper was based on certain study which can be put under fuzzy graph theory, and we were trying to obtain some results some ideas we had defined, and we wanted that classical result can be compared with our result. So corona was just gone, and everything in every research paper used to come related with corona. So we decided, okay, without asking anyone any question and without getting into इथिक्स, रिसर्च इथिक्स में घुसो मत यार। जो तुमको डेटा मिल जा रहा है उस डेटा के आधार पर एक एप्लीकेशन प्रॉब्लम बनाओ और ये पता करें हम कि ऑथर्स, डिफरेंट ऑथर्स के बीच में कंपटीशन और कॉम्पिटिशन क्या है। कंपटीशन तो हम सभी जानते हैं, लेकिन एक नया शब्द है कॉम्पिटिशन। कॉम्पिटिशन, कॉपरेशन भी है और कंपटीशन भी है। मेरी मूर्ति जल के सर के साथ कंपटीशन भी है और कॉपरेशन भी है। मेरे रिसर्च स्कॉलर्स के साथ मेरा सिर्फ कॉपरेशन है। सो अगर ऐसे कुछ रिसर्च वर्क हो रहे हैं जिनका कुछ एनालिसिस किया जा सकता है तो भाई करते हैं। तो ही डिड सम गुड वर्क एंड आई वाज टू मच हैप्पी। यू हैव डन वेरी नाइस। आवर मॉडल इज करेक्ट। our result match with earlier classical set theory result, classical graph theory से जो result आ रहा है उससे match हो रहा है और हम certain points पे better results दे पा रहे हैं। ओके, communicate कर दो भाई इसको। सो communicate कर दिया। और यहाँ मेरा क्वेश्चन था कि यहाँ कोई चाइना या ताइवान से तो नहीं है। अनफॉर्चुनेटली जो आई एम सॉरी, लेकिन हम लोगों में कुछ क्या कहते हैं मठाधीश प्रवृत्तियों के भी लोग होते हैं। तो वो मठाधीश केवल भारत में ही नहीं पाए जाते, देश विदेश में भी पाए जाते हैं। सो वो मठाधीश होते हैं जिनको हम कहते हैं रेफरी। हाँ सर, नहीं एक लाइन में रिस्पॉन्स नहीं मिला भाई मुझे, मैं लकी था। सो पहला मेरे को लगा यार ये क्या जर्नल है, अभी तक मैंने पढ़ा नहीं था कि 6 रेफरी होते हैं। 6 रेफरी, मेरे रिसर्च पेपर ने ऐसा क्या बवंडर खड़ा कर दिया भाई। Your research has been communicated. We find it very interesting. It has been communicated to various referees, and we will let you know. और कुछ समय बाद जब जवाब आया तो रेफरी नंबर 1 का ओपिनियन, रेफरी नंबर 2 का ओपिनियन, 3 का ओपिनियन, 5 का ओपिनियन। सो कुछ लोगों ने कहा नहीं रिसर्च पेपर बहुत अच्छा है, गो अहेड, यू कैन पब्लिश इट। एक रेफरी महोदय ने कहा थ्रो इट इनटू द डस्टबिन। क्यों भाई? रीजन? Because the author do not have a basic idea that Taiwan is an integral part of China. Please understand. Taiwan is an integral part of China. Authors do not know these fundamental things. This paper is liable to be rejected. ये हमें पूर्वाग्रह की बात करना चाह रहा हूं। वो जो जस्टिस थे, जो जूरी सिस्टम था, अरे भाई एक आदमी कह रहा है ये पेपर बहुत एग्जाम्पलरी है, नया सेटअप दे रहा है, और एक कह रहा है थ्रो इट इनटू द डस्टबिन। और क्यों फेंक दिया जाए? रीजन भी लिखना पड़ेगा ना आपको कि फेंक क्यों दिया जाए डस्टबिन में। बिकॉज ऑथर्स डू नॉट हैव ए बेसिक नॉलेज। तो मैंने अप्रोच किया कि भाई पॉलिटिकल साइंस के अध्यापकों से पूछ लूं कि मेरा जीके कहाँ जा रहा है यार। तो बोले नहीं सर, यू आर एब्सोल्युटली राइट, यू नो कि इस नेशन में ये हुआ। अरे मैंने कहा छोड़िए मैडम, सॉरी मुझे बोलना नहीं चाहिए था, जो भी हो। तो मुझे ये बताइए कि कैसे करें। तो बोले वो आप रेफरेंस लगाइए और भेज दीजिए। मैंने कहा मतलब एक बर्रे के हाथ में छत्ते में और हाथ डाल दूं, 1-2 पेपर अभी मुसीबत में फंसे हुए हैं, 1-2 को और फंसा दूं। सो मैंने कहा नहीं ठीक है, जाने दो भाई, क्या कष्ट है इस ऑथर को। थैंक यू टू द रेफरी, सॉरी टू द रिव्यूअर। अरे लेना भाई, एक बंच में डाल दे यार दोनों को, ताइवान और चाइना को एक ब्रांच में डाल दे। कंपटीशन और कंपटीशन यहाँ पे भी तो है ना। ले अब तो खुश, and you will be surprised that paper was published. Yeah, it's now correct. What we are doing? What we are doing? Can we judge quality of a research paper in this way? I will just like to conclude my talk. Not too much things I will like to say, but can you go for next? बहुत बोरिंग था भाई मेरा लेक्चर। हमारे पीपीटी मास्टर जो है वो सो गए हैं। थोड़ा सा और नेक्स्ट आगे पे जाएं। ग्राफ थ्योरी पे है कि नहीं? या यही वो पेपर्स हैं जिनके बारे में मैं अभी चर्चा करना चाह रहा था। ये बाइपोलर फजी ग्राफ्स को लेकर एक पेपर है जो एक और नया आइडिया था, और नया आइडिया को आप जानते होंगे, लुत्फीजादे का जो विरोध हुआ है वो तो exemplary विरोध है, लेकिन now we find that main is correct, and mathematics has to remodel everything. If mathematics is interested, then that we find application of mathematics somewhere in the real world scenario, then you have to widen the domain, and if you want to widen the domain, you have to get acceptability of from everyone. So how the things turn up? May I have the next slide, please? This is yet another paper which deals with ovarian cancer. So once again, another applicative aspect. Can you go for the next slide, please? Yeah, this is the paper which I was talking about, to throw it into the dustbin. Next, please. बहुत अच्छा, अगर खत्म हो गया तो ठीक है, इट्स गोइंग टू बी समवॉट रिपीटेड, या कोविड-19 वो भी सब चर्चाएं हो रही हैं. I just wanted to tell you, please do not go for that impact factor. Have confidence within yourself. Dr. Dhananjay is sitting, no, he just left. In fixed point theory, what I call is my best paper has no place anywhere. It is neither enlisted in UGC journal. अब जब UGC में ही नहीं है तो बाकी भी कहीं नहीं होगा. लेकिन अगर कोई पूछता है कि आपने फिक्स पॉइंट थ्योरी में क्या किया है, तो ठीक है, 20 पेपर होंगे, मैं कहूंगा सर ये मेरा कंट्रीब्यूशन है कि भाई आई कुड गिव समथिंग न्यू. आई फील इट इज न्यू. You are free to evaluate its noiseness. You are free to evaluate its applicability. And similarly, I'm going to talk about these papers. So when I tried to cover various aspects, I could cover economics, I could cover political science, I could cover social science, I could cover biological sciences, and possibly this domain can be extended to any area, provided that you are ready to throw away into the dustbin that one single ठेकेदार of uncertainty, theory of probability. स्टैटिस्टिशियन को ये चुनौती बहुत खराब लगेगी कि सर आप क्या बकवास कर रहे हैं. और यहाँ मेरा वो क्वेश्चन था कि अगर एक्सपर्ट, वन ऑफ द एक्सपर्ट अमेरिका से हैं, तो मैं जानना चाहूँगा कि व्हाट इज द रीजन USA is not doing much research on fuzzy set, fuzzy logic, while China, Japan, Taiwan, and these areas and these countries are doing extraordinary good. Is there any secret? I'm really even worried, because when I was working on one paper in application of fuzzy logic in making money, पैसा तो सभी बनाना चाहते हैं ना, तो मैं भी करता ही हूँ. अब बैठे हैं, सैलरी आ रही है तो नाव चले जा सकते हैं, मार्केट में इन्वेस्टमेंट कर दो, ये कर दो, वो कर दो. So when I was studying all these things, one professor from MIT mathematics wrote one essay, and then in the last he is saying, I will not disclose this secret. I want to make money by my own. But I'm sure fuzzy logic can give you this idea also. This was his remark. How many of you are from cricket, are loving cricket? My goodness, मैं अकेले ही हूँ क्या? अरे भाई दोनों हाथ खड़े करो ना यार. कई बार जीतता रहा है. यस, थैंक यू सर. भारत क्रिकेट में कई बार जीतता रहा है. भारत को अभी पटकनी दी थी कुछ समय पहले इंग्लैंड ने, राइट? और अगर आप उत्सुकता पूर्वक पढ़ते रहे होंगे अखबार, तो आपको अखबारों में ये जरूर पढ़ने को मिला होगा कि इंग्लैंड ने पूरा लॉजिक, फजी लॉजिक ही यूज किया था. They had pre-decided their every policy. अगर बारिश होगी जिसकी संभावना इतने प्रतिशत है और हम टॉस हारेंगे तो हम क्या करेंगे, अगर बारिश होना है और हम टॉस जीत गए तो हमें क्या करना है, फर्स्ट ओवर से लेकर आखिरी ओवर तक की स्ट्रेटेजी उनके पास प्लान ए, प्लान बी, प्लान सी के साथ तैयार थी. एंड वंस अगेन they acknowledged fuzzy logic. So this is the larger domain which I'm just trying to indicate you all people with a small torch. I do not have much khopri over here. I failed in mathematics. Thank you. Thank you.
मेरा नॉन मैथमेटिकल क्वेश्चन है, इतनी एनर्जी लाते कहाँ से?
Sir, you are absolutely right. I am 61 plus. Uh,
I think that will be the more appropriate question for our youngsters.
Yeah.
How to use energy in a way, in such a way that we can do everything like you agree.
Thanks for appreciating me. और तारीफ किसे पसंद नहीं है?
I observed that.
नहीं, yes, yes. I can say one more thing.
Sometimes we listen and people are not getting engaged, then no meaning of that lecture.
Yeah, absolutely right. Yes. आपने जो क्वेश्चन पूछा वो मुझे काफ़ी अच्छा लगा और कभी कभार मेरे पुराने रिसर्च स्कॉलर तो मुझे ये भी कहते हैं, आप सर फ्रिज में घुस के सोते हैं क्या? आपके सिर्फ बाल सफ़ेद हुए ठंड की वजह से, बाकी आप एज इट इज़ हैं, कोई चेंज आपके में नहीं है. Thanks to the genes which I borrow from my father and mother. First of all, I will have to say real thanks to my father and mother. And once again, next, this is rather beyond me and possibly beyond their hands also. They will be having genes from their ancestors. But now what makes me energetic, I feel, please don't spend time on negative thinking. जीवन में कई बार आता है, बहुत नेगेटिव क्षण आते हैं, जो अभी नेक की सफलताओं की बड़ी चर्चा हुई और जो पुराने मेरे कलीग्स नेक में मुझे जुड़कर काम करते हुए देखते हैं, वो महसूस करेंगे कि यस, कहाँ क्या राजनीति हुई, कहाँ क्या हुआ, रणधीर जी किस प्रकार से थ्रो अवे हो गए. आई डिडंट माइंड इट. डॉक्टर चतुर्वेदी, डॉक्टर एम के गुप्ता, डॉक्टर संतोष वर्मा, दे आर सिटिंग. जो कुछ हुआ, डिड इट रिफ्लेक्ट इन माई बिहेवियर? ठीक है, भूल जाओ. हर दिन एक नई शुरुआत इस उम्मीद के साथ करें कि मैं जिंदा हूं ना. थैंक यू सर, थैंक यू. चलिए, अब सर ने कह दिया तो हम आगे का क्वेश्चन, किसी क्वेश्चन पर आए. मैं यंगस्टर्स से चाहूंगा, क्वेश्चन के बिना. सर का क्वेश्चन मुझे अच्छा लगा क्योंकि ये मेरे ईगो को बहुत सेटिस्फाई करता है. लेकिन यंग ऑडियंस से मैं चाहूंगा कि कोई क्वेश्चन आपके दिमाग में है, कोई चीजें आपके दिमाग में आप चाहते हैं कि अपने रिसर्च को आप कैसे रिलेट करें इससे, तो आप उस पे या तो अभी पूछने के लिए स्वतंत्र हैं या जब कभी भी मौका मिलता है फोन पर आप मुझसे डिस्कशन कर सकते हैं. एनी क्वेश्चंस प्लीज? ओके, थैंक यू.
Sir, thank you very much. So now, sir, thank you very much, sir. Thank you. Now I would like to request Professor A.K. Thakur to facilitate Professor Singh, sir, for chairmanship of this talk. At the same time, we are also running a 7 parallel session in different places. Thank you, sir. So the time is for the tea break. Tea is ready just outside of this hall. So please enjoy it. Thank you. So those who are now going to present their paper, please prepare your PPT. We'll do it after the break, tea break. Now we are going to start the paper presentation session. So for the chairmanship, I request Professor Amrish Tiwari, sir, for chair this session. And for presentation, we have total at present the 5 presenter. So these are the names, and now I would like to hand over the mic to you, sir. Thank you.
Thank you, sir. Paper presentation session. First is Mani Shankar. Please come. What is your topic? Where your side? Yes. Mani Shankar, research scholar, CSIT department, GGVU. Okay,
sir.
please continue.
Myself Manish Shankar Sahu from the CS department, research scholar. And my presentation topic is biotic stress classification in rice crop using convolution neural network. Next. This is my presentation flow. Next. Here some introduction of my topic. Like we know that rice is primary food source for overall half global population, and additionally rice is a primary source of income every farmers in our country, and also rice is a contribute in global GDP. And here some like biotic stress negative impact on this plant. So there is a early detection and timely intervention is and protect the crop yield. Next. Some challenges in traditional method for detecting biotic stress, like labor intensive, time consuming, dependence on expert knowledge, limited scalability. So there we create a deep neural network which is detect automatically, extract a pattern from the rice leaf pest image. Next. We collect the data set from the Kaggle, which is freely available. These data set have 4 classes like Trungo, Blast, Bacterial Blight, and the brown spot. Next, sir. Some data pre-processing like removal, noise and blurry images, duplicate removal, and data augmentation, balancing classes, and data splitting. Next, sir. We use the deep learning approach like CNN. CNN is a convolution neural network which is inspired from the human brain. Next. Our model architecture CNN, there have multiple convolutional layer which is extract from the image patterns. Next. This is our workflow. Like our project is how work. Firstly, we gather rice leaf images from the field. Then we pre-process these images. After that, we split this data set into 2 parts, train and test. We train our machine from the training data set. After that, we test this machine, our testing data. Next, Karjit sir. Next. This is our result. Like our data set is imbalance. So there is a accuracy is 99.88%, which is not good, but we balance our data set. Next, sir. This is our model evolution matrix. Like our model is how accurately predict the diseases. Like highest accuracy is 99.83 when data set is imbalanced. Next. After balancing our data set, accuracy is 99.9991%. Next, sir. Like future work here, expand our data set because there is our data set with very little bit. So data set expansion, and next is a multimodal data integration, and next is a explanation AI. Next, that reference. Thank you, everyone.
Any question? Any question? You will find rice leaf diseases. You
Yes,
can
sir.
apply it in other leaves, potato leaves.
Yes, sir, we can apply, but
What types of disease you can find by the
sir, mainly multiple types of rice disease, but we mainly 4 types of rice disease work.
what the four types?
Bacterial blight, rice blast, and brown, brown spot or tango.
Uh, what type of machine you will use? Machine learning process?
Yes, sir, machine learning, CNN, deep learning. Deep learning, subset of machine learning, sir.
Okay, thank you.
Thank you, sir.
Next, Anurag Prakash. This is Scholar Department Mathematics, Patna University. Okay, please continue.
So, welcome to everyone. My name is Anurag Rakesh. I am a research scholar at Department of Mathematics, Patna University. The title of my presentation, as you can see, is Propagation of Torsional Surface Waves through an initially stressed non-homogeneous layer on a non-uniform half-space. Next slide, please. So these are the contents, and we come to the first part, that is introduction. Next slide. So waves. Waves in general sense is some form of disturbance that transmits from one part of a medium to another as the particles of the medium execute vibrations about their mean positions or positions of equilibrium. Sir, एक minute. Next is seismic waves. Seismic waves are the waves of energy caused by sudden breaking of rocks within the earth or explosion. These waves are of various types and they propagate in all directions from the source within the earth. These waves are detected by some sensitive instruments placed on or near the surface of the earth, and the readings are obtained on seismograph. Next, we come to types of seismic waves. Next slide. Seismic waves can be classified into two types, body waves and surface waves. Body waves, as the name suggests, the waves which travel through the body of the media or the earth, and surface waves travel along the surface of the media or the earth. Body waves can further be classified into two types, P waves and S waves. And surface waves can basically be classified into three types, Love wave, Rayleigh wave, and torsional surface wave. Next slide, please. First type of body wave, that is P wave. P waves are also called primary waves. That is because these are the waves that arrive first at a seismic station, being fastest of all the seismic waves, and are longitudinal in nature because the vibration of the particle is along the direction of propagation of the wave. The wave velocity is a function of wavelength, shear modulus, and rigidity. The velocity is about 6 km per second at the surface of the earth, which increases with depth to about 10.4 km per second near the core. But as it enters the core, it drops to 8 km per second and it again increases to about 11 km per second at the center of the earth. Next slide. S waves. S waves or shearing waves or secondary waves or transverse waves. These are called so because secondary waves because this wave arrives after the P waves at a seismic station. Transverse because the particle vibration is perpendicular to the direction of wave propagation. And shearing because these wave requires what we call shearing resistance, which is available only with solids but not fluids. So this is the difference between P wave and S wave, that S wave can travel only through solids but not fluids, but whereas the former one, P waves, can travel both through solids as well as fluids. Uh, on the basis of polarization, there are two waves. Please move to next slide. Surface waves. Surface waves are generated due to interaction of body waves with free surface or boundaries between two layers or a layer and a half a space. The first type of surface wave is love wave, introduced by mathematician cum seismologist August Edward Hugh in 1911, Hugh in 1911, and these are basically horizontally polarized transverse waves and the most destructive wave of all the seismic waves. Uh, these waves are generated due to interaction of SH waves with the free surface. The velocity depends on the wavelength, the thickness of the layer, and the elastic properties of the two media at the stratified layer. And one superficial layer, that is free surface, is necessary for its generation. Otherwise, it will not propagate. It does not propagate in develop in homogeneous half space. Next slide, please. This is the animation of love wave. You can see that motion of particle is in horizontal direction, but the wave is moving in radial direction. Next slide, please. Rayleigh waves, introduced by British mathematician cum physicist cum seismologist Lord Rayleigh in 1885. These are vertically polarized waves, and the particle motion is elliptical, retrograde to the direction of wave propagation. So there is no motion of particle in vertical plane. The velocity is about 90% to that of L wave, and they can exist in both homogeneous surface space as well as in layered one. Next one, torsional waves. Actually, I am working on these types of waves only. A kind of surface wave which brings a twist, एक निचोड़ लाता है एक मीडियम में, twist in a medium about a central axis. For non-homogeneous layer, half space, the velocity is always greater than.
Please go to model. Directly go to model. Formation.
Next slide. Okay, this is my model as well as geometry of the problem. There, the upper part is the layer and the below part is half space. I have used cylindrical coordinate system, that is axial, circumferential, and radial, circumferential, and axial coordinates denoted by r, theta, and z respectively. N, L, L are directional rigidities in r direction and z direction respectively. Rho is density. P is initial compressive stress. Initial stresses are pre-stresses present in a media. And all these have hyperbolic variations depending on z. Next, we come to half space. Half space is showing polynomial variations where mu is rigidity and rho is density. Next one. I have described all that. Next slide. Next slide. Okay. No, sorry. एक slide पहले आइएगा. The equation 1 is the standard equation for initially straight anisotropic layer given by Biot. So this is not my equation, this is standard equation. And after substituting the values for initial incremental stresses, I have obtained equation 2, and then I have assumed non-dimensional coordinates r and zeta. Next slide. And this substitution is done to make the equation simple, look beautiful. I have obtained equation third, and then I have used variable separable method. You can see v is equal to v1, v2, and move next slide. And that is the solution part and substitution part and all that. I have obtained one more next slide. This equation 9 as the solution for this layer. This is my solution. Now we come for solution of half space, which is in next slide. Next slide. Yeah, the set of equations 10 is again a standard equation given by Biot. The symbols have their usual meaning, and the equation 11 denote stress-strain relations. Again, these are standard equations.
Please go to the results.
Okay. So, yeah.
Please define boundary conditions.
Yeah, there are three boundary conditions, one with free surface, another with the interface. With free surface, we have shown that there is no pre-stress. With the interface, there is continuity of stresses in the upper layer and in the half space, and one more continuity is of displacement. So these three are boundary conditions. I have obtained three equations for these three conditions.
You have any graph?
No, sir, no graph.
How to define the that type of physical terminology?
Sir, actually, this is a review work. This is not my original paper. It has been only 3 months of my registration. So,
Okay. Any question, please? Any question? Please.
Have you know about a Stonely wave? Stonely wave. Have you know about?
no, sir.
It's a surface type wave. As
Yeah,
you discussed, love wave,
yeah,
Rayleigh
yeah.
wave.
I have used the term. Basically, there are three types of surface waves. There are more G waves and more, and one is that also. I don't know that, but in my study, I have considered three types of surface waves. That is Love, Rayleigh, and torsionous surface wave.
You have used isotopic for media, right? Isotopic layer.
No, the layer is anisotropic, but the half space is isotropic.
Isotopic.
Yeah.
What the term is due to isotopic?
What is isotropic? Isotropic means the physical properties which we are considering is same in all the directions. And anisotropic means they are different in different directions.
Okay. Thank you. Any other question?
You have take cos hyperbolic function of Z.
Yes, sir.
Why you take cos hyperbolic function?
Sir, we can take different functions also, like sinusoidal and logarithmic function, exponential function. Actually, I came to know, this is a review paper, that there is little bit work done on hyperbolic functions.
It means this is not your research paper.
No, it is not research paper.
Only review paper.
Review paper. Yes.
So if we take a sine hyperbolic function of Z,
Yeah,
then
you
what
can.
happen?
Yeah, sine and cos are all the same.
Because you talk about the seismic graph,
Yes, sir.
sinusoidal or seismic graph वगैरह.
Yes, sir.
So why be you take also sine or exponential function of Z?
Yes, sir. I can assume different mathematical formulation. There is no restriction in that.
Sir, want to say that you can single term e raised by I theta, then you have the both sine of cos term. Why you take the cos only?
Sir, this is not my original paper. Review paper. I already told me. This
Okay,
is someone else's work.
Thank you very much. Next, please, Bhumika.
Good evening to all of you. My name is Bhumika Pandey. I am from Ayodhya. I am a junior research assistant in Rajki Engineering College, Manpuri. This is my exponential time dependent microplastic transport in aquifer. Next slide. These are my contents. Introduction. I will explain process of plastic becoming microplastic. As the plastic spends more time in the water, it gets weakened by waves and UV light from the sun, and eventually it breaks into tiny particles, pieces of plastic known as microplastic. Next slide, please. Microplastic, it is less than 5 mm and occur in the environment as a consequence of plastic pollution. There are two main sources of microplastic: primary microplastic and secondary microplastic. Primary microplastic such as polyethylene, polystyrene. Sorry, ma'am. Oh, sorry. I'm so sorry. Sorry, sir. प्राइमरी माइक्रोप्लास्टिक सच एज पर्सनल प्रोडक्ट जो हम यूज करते हैं, जो पर्सनल प्रोडक्ट यूज करते हैं। और सेकेंडरी माइक्रोप्लास्टिक क्या होता है कि जब वो प्राइमरी माइक्रोप्लास्टिक जब वो ब्रेक डाउन होता है तो उससे जो माइक्रोप्लास्टिक होते हैं मतलब फॉर्म होते हैं उसको हम सेकेंडरी माइक्रोप्लास्टिक कहते हैं। Plastic does not composed, it is just converted into small particles. It is very harmful for our life, aquatic life, environment, and etc. Plastic bottle can break up into thousand of microplastic. वी आर जैसे हम क्या करते हैं कि प्लास्टिक बॉटल हम यूज करें लेकिन हम ये नहीं सोचते हैं कि इसमें कितना माइक्रोप्लास्टिक होगा जो हमारे बॉडी के लिए हार्मफुल होता है। और एक्वेटिक लाइफ में जैसे ओशियन हो गया तो ओशियन में इतना ज़्यादा माइक्रोप्लास्टिक की जो क्वांटिटी है बहुत ज़्यादा हो गई है। अकॉर्डिंग टू यूनाइटेड नेशन एनवायरनमेंट प्रोग्राम द अमाउंट ऑफ प्लास्टिक पॉल्यूशंस in 2023 was 430 million, of which two-thirds goes into the ocean and gets converted into microplastic. Approx 95% people ऐसे हैं कि जो सी फूड पे डिपेंड होते हैं और सी फूड्स में जो भी एक्वेटिक एनिमल होते हैं वो माइक्रोप्लास्टिक को क्या करते हैं कि अपना फूड समझ के उसको खा लेते हैं। और सी फूड्स के ही थ्रू हमारे बॉडी में माइक्रोप्लास्टिक आ जाता है और हम उसको इमेजिन नहीं कर पाते हैं कि हम पर डे कितना माइक्रोप्लास्टिक कंज्यूम कर रहे हैं, साल से हम कितना माइक्रोप्लास्टिक कंज्यूम कर रहे हैं। एंड ग्राउंड वाटर में अप्रोक्स 5.5 एवरेज में माइक्रोप्लास्टिक है। और ये जो ड्रिंकिंग वाटर हम पी रहे हैं मे बी कि इसमें भी कई सारे माइक्रोप्लास्टिक थाउजेंड ऑफ माइक्रोप्लास्टिक होंगे। एक प्लास्टिक बॉटल से 10,000 अप्रोक्स 10,000 से माइक्रोप्लास्टिक कन्वर्ट होता है। नेक्स्ट स्लाइड प्लीज। Objective in this paper, we use a solute transport model. Is very effective for tracking microplastic in the drinking water. The primary objective of this paper to evaluate the toxicological study of plastic debris in the drinking water source in remote areas using a parametric simulation of solute transport technique. प्राइमरी हम क्या करेंगे कि सबसे पहले हम आइडेंटिफाई करेंगे, सिमुलेट करेंगे कि माइक्रोप्लास्टिक कहाँ है, ग्राउंड वाटर में है कितना और सरफेस वाटर में कितना है। देन
Please go on solute transport model. Please go in formulation part. Mathematical modeling, what is you will use?
next slide please.
Please describe the geometry.
We change
Previous slide. Yeah. What is this?
transport of MPS in saturated porous medium. This is a medium primary permeable soil is volume is equal to 1, attachment and impermeable soil detachment for volume 2. माइक्रोप्लास्टिक इन द एक्वेस फेज में क्या हो रहा है कि जो सॉलिड फेज में जो भी माइक्रोप्लास्टिक है वो अपर साइड एंड लोअर साइड में है, अटैचमेंट इसका हो रहा है। और उसका जो डिटैचमेंट हो रहा है aqueous phase में उसका middle में है। तो porous medium in this paper we use a porous medium because it is suitable for predicting the microplastic in the water and groundwater and surface water.
Mathematical model.
We change the boundary condition of we in this paper we use a one dimensional advection diffusion equation. This is my model. Del C upon del T is equal to D del squared C upon del X squared minus V del C upon del X minus KAC. C is equal to microplastic in the aqueous phase, number of meter cube. V is equal to average pore water velocity and D is equal to diffusivity. Del C upon del T, rate of change of concentration with the time and derivative. Del C upon del T, spatial gradient of concentration indicating how concentration changes along the x direction. Del square C upon del X square is the second spatial derivative representing the dispersion spreading of the concentration. K is equal to the first order attachment coefficient. Next slide. how to calculate Ka? Here Ka is equal to the first order attachment coefficient. Ka is equal to 3 1 minus theta upon 2d 50 NAQ, and is equal to collector porous medium efficiency. Alpha is equal to microplastic sticking efficiency, and v is equal to mu is equal to pore water velocity.
Please go on boundary conditions.
Next slide, please. We use advection dispersion equation model. Next slide, please. These are some parameters. The boundary condition. This is a Dirichlet and Newman boundary condition, which is used in this paper. These are a result.
Conclusion.
So next slide. D is a diffusion coefficient value 0.01. In this slide, when the concentration of microplastic decrease with length. First graph, and second graph, the concentration of microplastic decrease with a time.
Go on conclusions. Conclusion.
So I can explain.
What about the bulk density? What effect to measure the bulk density by the graph? Here we mention the effect of microplastics in sinking storage or so on. What is bulk density?
Sir,
Effect of bulk density in the graph. How to show it?
सब बल्क डेंसिटी ऑफ सॉइल मीन्स कि सॉइल के पास कितनी कैपेसिटी होगी वाटर को होल्ड करने की.
Any questions?
Thank you so much, sir.
Okay, next, Prajwal. Department Mathematics, IIEST, C4. Okay, please.
Good evening, rather, to one and all present here. Myself, Prajwal Parmar. I'm a senior research fellow from Department of Mathematics, IIST Shivpur. And I'm here to present, share my ideas, or basically you can say research work, which is generally based, I can say it on the entitled Analytical Investigation of a Two-Dimensional Thermoelastic Bioheat Problem Incorporating Fractional and Memory-Dependent Derivatives. We will get to the each and every slide thoroughly so that you can decode why the title is this and what we are trying to approach in this particular method. Okay, but before starting the presentation, I will take a minute to pay my gratitude to Guru Ghasidas Vishwavidyalaya for providing me this platform to share my idea. And I would also like to thank my supervisor, Smita Paul Shakar, who has been a constant rock support to me through highs and lows and has always supported me, no matter what's the cost. So, okay, without wasting much time and taking the permission from the reference, I would like to move on to the next slide, sir, please. This is how we will going to distribute the presentation in some contents so that you can get an idea of what we are actually trying to decode. And I hope there's people from many other departments. So it just give a gist of what we are trying to incorporate through this presentation and how we can collaborate or work in this in upcoming futures. If the time permits, I will share my details also if you are interested. Okay, we can go to the next. Just hit a slide. Okay, what is thermoelasticity? Consider you are taking an body, any elastic body. When there is a change in that, any deformation in any solid body, let's say this is mine. One of the causes is heat. When you provide heat in this body, the shape of this body changes. Thus, there is a deformation. So we can say that when a heat is given to the body, there is a shift in a temperature, making the internal energy of a body becomes a function of this deformation and temperature. And the field of science that deals with this coupled science process is basically coined the term thermoelasticity. Next click, please. Can I have a click? Okay. And what is the interaction with thermoelasticity in recent days medical therapies? We all have heard the word cancer, and the first thing that fears our soul out after hearing cancer is that, oh, just get over it and get free from this. So in recent times also, the major cause of death in any country, if you take a UN data, is cancer only. So it becomes very necessary to kill those cancer cells or rather tumor cells in an infected body, providing an essential amount of heat. There's a process called hyperthermia, diathermia, thermal ablation, radiotherapy. There are many names to it, but basically no, so that's okay. So because it will get too late. Okay, okay. So basically, it gets very essential for us to how can we kill that cancer cell or tumor cell in that process without affecting the healthy cells which are residing nearby that particular area or particular body. This is where the thermal analysis or thermoelasticity come into play. Okay, sir. Can we move on? Can I hit a button? Okay. What is thermoelastic models? So very essential, very early 1958 thermoelastic model was introduced. Biot gave an classic thermoelastic equation based on classical Fourier's law of equation that was a parabolic equation. And after that, a few times there was a time. There is always a time to change. So Cateno and Bernot, after 10 years or sorry, after a few years, they introduce a phase lag term in that Fourier's law to make it non-classical, thus refining the classical Fourier model. They have introduced tau. You can see that's the heat flux, phase lag parameter because of heat conduction problem. Okay, can I hit the next button? And this is the ramp type heating, which I'm generally the mathematical approach for taking the ramp type. I'll be using it as a boundary condition. But ramp type heat is a process. It also has its significant applications that it helps in cryotherapy or extremely low temperature. It reduces the inflammation. It promotes highly healings and restricts blood flow in many cases. Can we move on? Okay, one more thing. Fractional order derivative and memory. This is interesting. We have all heard that ddx of x square comes x, d square x, d square upon dx square of x square become 1, d cube x, dx cube becomes 0. So it's a process we all are taught very early. But in 1695, Leibniz first thought, why we are taking n as a positive integer only? What will happen if I conclude this to half? What it get to negative integer? That's when fractional order came into play very early at that particular stage of time. And after that, it has been involved multiple times, taking and still the work in progress. So there is a lot of opportunity in fractional calculus where it has been refined over the period of time. Fractional order derivative, there are two main derivatives which we generally use. The first one is Riemann-Leibel fractional order derivative, and second is Capito fractional order derivative, which is generally taken in case when analyzing mathematical frameworks. Recently, memory-dependent derivative came into play because there were some limitations in fractional order derivatives. In 2011, Wang and Lee generally reduced this method, which was based on the memory effect. Basically, in fractional order, the kernel was fixed. There are only one interval from which the memory was taken. But in memory dependent derivative, you have the flexibility to choose the kernel, thus improvising your result throughout the period. Can I hit a next button? Okay, these are some application, memory scope, and the limitation which I have told you, there is a fixed kernel and a fixed memory scope, which is not ideal for all application. And there, that's where memory dependent derivative comes a handy advantage. Okay, next. Okay, motivation I have told you, I'm just trying to make a social impact by introducing mathematics, highly responsible in the field of medical therapies. These are the symbols which we have generally used throughout the paper, throughout the presentation to describe. If I'm bounded by time, but if anyone feels a bit complexity, you can ask me, I will revise it or reschedule it. Okay, can I get a next? Can I hit it again? Once more. Stop. See, this is the general skin tissue which we take into consideration. Our skin tissue consists of upper layer, that is skin, followed by a epidermis, dermis, and hypodermis layer. In one of the layers, suppose there's a cancer cell tissue is there. I'm taking that general model. I have nothing to do with it. The biologists deal with it. I'm considering this mathematical approach for that particular model. So I'm taking it in a two-dimensional space. There's no work considerably done in two-dimensional space considering this fractional derivative or memory-dependent derivative. So now we are applying heating process that is applied as ramp type heating in that two-dimension space. So how to get advantage over the previous results or previous models of thermoelastic. Okay, can we go to the next? These are the basic building blocks of any thermoelastic problem. It goes through Biot equation, entropy equation, stress-strain relation, equation of motion. And after combining this, we get a generalized bioheat conduction equation, which has been mentioned. Can I get next? Thank you. Just stop there. Basically, non-dimensionalization process of governing equation. I have non-dimensionalized. Non-dimensional plays a very important role, because when we are dealing with system of coupled differential equations, it becomes very lengthy, and while plotting the graphs, it becomes not, the scaling becomes very critical when there is a large quantities are present. So to maintain a difference and to get what is the viable difference, we have to non-dimensionalize the quantities. For this particular system of solving system of differential equation, I have taken displacement potential approaches, which is generally given in the terms of displacement and phi and psi are two displacement potential functions. So basically, we are reduced to three basic partial system of differential equation. That is first, second, and if you are taking fractional order derivative, then that, and memory
Please go
dependent
to
derivative,
result
then that.
parts.
Huh?
Results part. Please go to
Yeah,
result
yeah,
part.
sir, sure. Just give me 2 minutes. Okay, can we get next? Just get, okay. So Laplace Fourier transformation, we are doing the analytical solution. So for that, we are applying Laplace Fourier transformations to get into Laplace Fourier approach from changing it to space-time domain. And Laplace Fourier transformation is useful because in analytical approach, there is the equation where you are dealing with a coupled system. In one equation, you have three variables. So if you convert into an, like Laplace Fourier transformation, it becomes very easy to deal with. These are the required solution. I've skipped the numerical calculation. These are the results which we obtained. Can we go through the next? Give just once, just one. Initial conditions are mentioned over there. Boundary condition, I have considered RAM type heating that I have explained through diagram, and I have converted the RAM type heating into the transform domain also. Can I go through the next? Okay, once more, just. So while we are plotting the numerical results, it's important to inverse that, because we have taken solving the solution in an like transform domain. So it becomes important to reverse it or inverse that transformation. So Steffes algorithm I have used to for the inversion of Laplace transformation, and Fourier transformation I have taken for the inversion. Gaussian quadrature, 7-point Gaussian quadrature method I have used for the Fourier transform in the inversion method with the help of obviously MATLAB. Next slide. Okay, this is where it comes handy. You can see that this is the graph, which is very peculiar with its boundary condition. I have taken that at temperature at x is equal to 0 will be equal to T upon T naught. If you get T, that is 0.085 upon T naught, it will give you exactly value that 0.0281, and the stress is 0 at 0, and velocity thus gives the required result. So basically, one thing is clear, that whatever numerical we are doing, it aligns with the boundary condition. Thus, our numerical is correct because it's satisfied with the programming. And here I've shown you the difference between how the fractional order derivative and memory dependent derivative, there's a difference between both of them, and how is memory dependent derivative much more better result. It can provide a much more better result. Okay, can I go through the next? And then on the other hand, there is a RAM type heat effect, where I have modified RAM type effect and two models, that was Fourier's model, classical and non-Fourier's model. I have shown the difference between that two and how the introduction of phase lag in single phase lag model has benefited us. Okay, next slide. Okay, one more. So these are the concluding remarks, that graphical results aligns with our boundary condition. Second is thermal injury decreases as time dependent time increases. Memory dependent derivative gives the edge over fractional order derivative. And fourth, the RAM time heat parameter is playing a critical role that in the giving temperature response and killing of those tumor cells. Potential areas of further study. That is one thing I would like to say, that it's not possible that cancer cells are there. Cancer cells are present in various parts of the body in various forms. I have taken a Cartesian coordinates. It can be polar coordinates also, blood cancer, or in a bone cancer, whatever things. So the structure changes, and we can vary over that. Second is that fractional derivative has emerged very rapidly. Now Antegna Beleno has now came into play. Conformable derivative, tempered capital derivative has came. So these are some future investigation projects. And we can also, like I have taken displacement potential approach to solve this analytical problem. There is eigenvalue approach, there's normal mode analysis, finite element techniques, finite Fourier transformations. So we can recent work on that also. Okay, next part. These are some references which I have used throughout the my work. Next. This is a bit about me. Like I'm a senior research fellow in this ISC that I've already mentioned. This is my team of PhD, and that's my from graduation, Acharya Nareन्द्ra College, Delhi University. These are my details. If anyone feels free to work in collaboration in recent times, they can feel free to contact me. I've published one paper in the Springer Journal. One has been accepted. A review has came for 2 or 3 journals, and 2 or more are in the communication stages. So this is about me. Next slide. So this is thank you, and I would like that if any of you have questions, I would love to.
Any question, please?
Yeah, sure.
Two-dimensional in first one. Yes. What are the two independent things that generate the remaining? I mean, you have used two dimensions.
So like I'm taking suppose you are considering a sheet. So then the explain and y plane. So I'm taking two-dimensional sheet problem. Okay, sir.
Lack of time, please, after the. You can use analytical method as a numerical method.
No, sir. Sir is saying that the graph, the pictorial graph of two dimension.
Two dimension, you can play surface graph. You cannot play the one dimensional graph.
So then I'm because throughout the papers I am going through, there is like this pictorial.
Okay, okay, thank you. Okay, fine. Thank you. Thank you very much. In this session, last presenter is Sunny. Yes, yes. I have the 5 candidates only. List of 5 candidates. Anyone can add this?
Good evening to all of you. My name is Sunny Kumar. I am a research scholar at Department of Mathematics, Patna University. Topic of my presentation is role of initial stress in love vapor propagation through anisotropic porous layer. Next slide, please. These are my contents. Next slide, please. Next. Introduction. First, we introduce wave. Wave is a some form of disturbance which is transmitted from one part of the medium to another part as the particles of medium through execute vibration about their position of an equilibrium. Next, seismic wave. Seismic wave are the wave of energy caused by sudden breaking of rock within the earth. They are the energy that travel through the earth and recorded on seismograph. The propagation velocity of seismic wave depends on rigidity and elasticity of the wave medium and as well as type of the wave. Next slide, please. Generally, seismic wave have two types, body wave and surface wave. Body waves categorize into two parts, P wave and S wave, and surface wave has three parts, love wave, Rayleigh wave, and torsional surface wave. Body wave is also known as a seismic wave that travels through the Earth's interior, and surface wave also known as a seismic wave that travel along the surface. Next slide, please. This is my elimination of P wave. P wave is also known as a primary wave. It is deformation propagate particle motion consists of alternating compression and dilatation. Particle motion is parallel to the direction of wave propagation. It is frequently used in ultrasonic testing. P wave can move in solid rock and liquid. Next slide, please. S wave is a second type of body wave. S wave is the velocity of S wave is about 60% of P wave. It can move in only solid rock. Next slide, please. Basically, there are two types of S wave, SH wave and ASB wave. If the S wave is polarization in horizontal plane, then it is called SH wave, and S wave is polarization in vertical plane, then it is called SB wave. This is a type of surface wave. Rayleigh wave is also known as R wave. It is a polarization in vertical plane. Next slide, please. Love wave is also known as L wave. These waves are introduced by Lord Rayleigh in 1885. It is a vertical polarized wave. Next slide, please. These are formulation of my problem. Here, upper position is a layer equation of a surface of layer, and lower position is the semi-infinite medium half space, where H is the depth of the layer, and N and L are the directional rigidity, and rho is the density. And M is a constant and taking a quadratic variation. And below part is the surface half space of the layer, and mu is a rigidity, and rho is a density. P is the initial stress. Next slide, please. Next slide. This is a solution of layer equation. First is a basic equation of layer, and using variable separable method we get, next slide please, equation number 8. Next slide please. And this is a half space of my problem. Equation 9 is a standard equation of half space. Generally half space is a semi non-homogeneous half space. And next slide please. And solve the equation number 7, we get a equation number, next slide, 18. This is a basic equation of half space. Next slide. These are the boundary condition of anti-dispersion equation. There are three boundary conditions. First, the continuity of a stress required that, and second is the stress is vanishing, and third is the continuity of displacement required. Next, and please previous slide. Using the using equation number 20, 21, and 22, and remove the constant term a, b, and d1 from the determinant method. Next slide, please. From the determinant method, we get equation number. Next slide. We get this equation. This is a basic general equation of our dispersion equation. These are my references. And next slide. Thank you.
Okay, thank you. Any question, please?
So love baby is given by the A.S. Love in 1911. I am. Oh, surname. Yes, sir.
Definitely, you can define by the equation of the wave and thermal longitude, phase difference. You can define love wave.
So love baby is generally given by the Lord A.S. Love in 1911. Love baby is also known as a L wave, and this wave is horizontally polarized.
Phase difference here, love wave. Without phase difference, wave cannot give.
Sir, question. Sorry, sir.
Okay, thank you. Anyone? Anyone left? अभी इसको प्रेजेंट करना है, कर सकते हैं।
Hello. Hello. Good afternoon to good evening to all of you. So myself is Dr. Santosh Verma, Assistant Professor in the Department of Mathematics, Guru Ghasidas Center, University, Bilaspur. आवाज आ रही? So first slide. So my topic is the थोड़ा सा बड़ा करिए ना. So my topic is some fractional calculus operator associated with generalized Mittag-Leffler functions. No. So fractional calculus area introduction. This is the special function. This is the part of the special function. So fractional calculus. In the power of n is equal to 1 by 2, 1 by 3, 3 by 3, 5 by 3, 7 by 5, and so on. So f n is equal to 1. Next slide. So this is the special function is the Mittag-Leffler function. This is the one variable. So one variable, two variable, and three. So generalization E alpha z is equal to summation n is equal to infinite to 1 upon gamma alpha plus 1 and z raised to power n. So z alpha belongs to complex or alpha greater than equal to 0. And this is the two variable alpha or beta. This is a generalized Mittag-Leffler function. And two variable summation n is equal to 0 to 1 upon gamma n plus beta z raised to power n. So z alpha beta belongs to complex number or the real alpha greater than 0, real beta is greater. So this is the condition of the with C being the complex number are known as the Metek-Leibler functions. E alpha z was the introduced by the Metek-Leibler. Metek-Leibler is the mathematician, also name is the. So E and E alpha beta was the introduced by the Bimans mathematician. The main results is the special theory. Classical theory of these function can be the found of the handbook Adley et al. Three mathematicians in 1953 and more results of the given by the book of 1965, 93. Next. So the Parker 1971 introduced by the, this is the generalized Metek-Leibler function. This is a three variable alpha, beta and gamma. So in the form of the beta summation. So gamma n numerator upon denominator is the gamma n plus gamma eta or factorial n. So z raised to power n alpha beta gamma belongs to C. Real alpha greater than 0, beta greater than 0, where gamma n is the Pochamer symbols. So defined by the Pochamer symbols, this is the very important condition, very useful the condition of special function. So Renville book is the best. So where is the n n plus gamma plus n upon gamma is equal to 1. This is the condition. If n is equal to 0, so condition is 1, or if n belongs to n number wise, so gamma n plus 1, gamma plus 2 and so on. So where n is equal to 1, 2, 3 is the set of the nature number n 0 is equal to n union 0. The function E alpha beta gamma z, this is the generalized exponential function, is the Metek-Leibler function alpha. Billman's functions is the Gorenflo et al. This is the book. Kilvas and Sago investigated the several properties, applications, and the function defined under 1 to 3. So next. So recently, Salim the 2009 introduced by the generalized is the Metek-Leibler function is the 4 variable. So this is the also generalized Metek-Leibler function and a variable alpha, beta, gamma, and delta. So equivalent to Metek-Leibler function or M series. M series is my colleague that defined of the 2009, and Manoj Sharma is the, and Professor Renu Jain also defined the equivalent to generalized Metek-Leibler function or M series. So and alpha contains is the form maintains Metek-Leibler function, not that the alpha. These are the condition is the gamma delta is equal to 1. So this is the special case of the put the value of the gamma, alpha, beta, gamma. So real back to the Metek-Leibler function is the 1 variable. And those investigation we shall use the fact to study various properties relation of the functions E alpha beta gamma delta z. Here this the section we have the study fractional into integral operators introduced by the Sago, and in 1978 or Sago made the operator, two mathematicians. So this is the only Sago operators. So contains the generalized Metek-Leibler function, define the equation number 5. So and the kernels. Next. For example, Metek-Leibler function, the base of the Metek-Leibler function denoted by
Please
the
go to result side.
Yes. So these are the conditions. And next parameter generalization, fractional integral derivations is the fractional into derivative required the defined by the Sago operators. So Sago operator, this is the integral part of the and differential part, equation number 7. This is the definition of Sago integral. Next. So fractional integral alpha is equal to, this is the condition of the second kind Sago operator. Next. So the Riemann-Leibler, Weil and Adlich fractional operators. This is the Riemann-Leibler is the original operator of the fractional calculus. All the operators is the generalization of the many mathematicians fractional operators. So this is the definitions of the integration and differential Riemann-Leibler, Weil operator and Adlich over. Next. So this section is the made the right of Riemann-Liouville fraction operators. I said Riemann-Liouville fractional integer operator, which is the study of the Kilwas 2006 and the Lin et al. 2004. Define this is the equation 13 and 14. Next. So introduce the right side of the fraction. Two type of fraction, and Riemann-Liouville left side fractional derivative or Riemann-Liouville of the right side fractional derivative. So both are the many condition difference are different conditions. Next, please. Sago fractional integer main result is the main functions of the Sago integral operation with Mittag-Leffler function. So many function or kernel change we so find the different result and find the with different conditions. So this is the result of the number equation number 16 generalized Mittag-Leffler. So many also this is the put the value of the alpha, beta, gamma and delta. So these are the special cases. And please next. So this is the result of the next equations. Please. This is the proof of the equation number 16. Let us the take of the left-sided Riemann-Liouville integral with the generalization Mittag-Leffler functions. So these are the results, and putting the t upon x is equal to u, interchanging the order of integration summation, which is the permissible under condition state, and then using the beta integral property we get. So these are the result. Man, next please. Equation number 19 is similarly we can prove also the results of the Riemann-Liouville Weil operator, Eddy-Kober operator, fractional calculus involving the generalized Mittag-Leffler function. Please next. So equation number 20 and 21, these are the special cases also. And next please. These are the special cases. And next 24, 25 and next 26. Okay, these special case put on the delta is equal to 1, delta or gamma is equal to 1. This is the main results is the put the value or different cases. Next. So delta gamma is equal to beta is equal to 1 in the. So these are the results. Next. This is the theorem. Please back. This is the theorem, let x greater than is equal to a, alpha belongs to R real. So 0 to infinite, 0 less than, this is the gamma between the 0 and minus, nu between the 0 and 1. So real alpha maximum, this is the real delta minus gamma is the results. And then next. So these are the results of the, please next. Prove this. Next, proof this using the equation definition is 28 equation. So using by the definition and side the written as the equation and generalized Mittag-Leffler function expansion, the formulas. These are the many formulas we can find. And next, please.
Okay, time is over.
Okay, please next. These are the also special cases in the next term. Please next. These are the references. Thank you.
Any question? No. Okay. Thank you very much.
Thank you, sir.
In this session, we have total number of 6 paper presentation. Okay, everybody presented very nice. Okay, I think so. Anybody else who want to present? No. Okay, thank you very much, everybody.
Okay, thank you, sir, for hosting this session. Now we came at the end of today, and tomorrow we'll be starting from 9:30 a.m. and first keynote, the second keynote lecture by Professor Rajendra Pan sir is from University of Johannesburg, South Africa. So his lecture will be starting from 9:30 a.m. So I request all the participants and all the members who are present here, please join with us so that we can continue our session in time. Then there will be 4 invited lectures by Dr. Subhas Khajanchi, Dr. Anand Kumar Tiwari, Dr. Ambrish Kumar Tiwari, and Professor Sudhakar Kumar Chobe. And from 12:40 onwards, we'll be conducting these parallel sessions for paper presentations. And today we have already completed 6 online parallel sessions, and they are near about 60 papers have been already presented. And the lunch on tomorrow will be from 1:30 to 2:30 in the same venue, and our valedictory section will start from 2:30 p.m. onwards. Thank you all for being present here. Thank you very much. चार्मिता थोड़ा मोमेंटो और please one moment. I just so one thing we just want to felicitate our session host Dr. Ambrish Kumar Tiwari sir. He is from Department of Applied Science and Humanities, Rajikya Engineering College, Mainpuri, UP. So I request our HOD sir to honor Dr. Ambrish Kumar Tiwari with a token of memento. Thank you very much. So we'll meet tomorrow sharp at 9:30 a.m. I request you all to please come at time so that we can start our session timely. Thank you very much.